Do you know what? I'll just click the thing to go live and I haven't turned my lights on. Let's get some lights going so you can see me a bit better. Hello. Right, audio seems to be working fine, it's good. Let's turn that light on, hold on. Does make a difference. Right. Does the camera look a bit high? Was it just me getting shorter? Yeah, something like that. So if you're here watching, say hello to me in the chat. Go and pop up in there so I know who's here. David, Justin, how's it going? Right. So what should we play with today? So we've got a few things I could potentially look at. The first thing is I'm streaming today because I wasn't supposed to be streaming today. I was supposed to be working at an event, but the event got cancelled because it got locked down on beginning of the week. Just for a few days, like a 3-day lockdown. Started on Sunday night, finished on Wednesday night, and those 2 days I couldn't get to work. Border restrictions, they actually stopped me from getting, it's actually a police checkpoint there and they can't get across it. So I couldn't get to work. So I had a few days off. So I played around a couple of projects and I did some work on a project which I've been meaning to get done for a while. I finally got stuck into it, so that's done, finished, thankfully. I'll tell you about that actually. I've done a video on the LoRa to Wi-Fi gateway. Hi Q's, how's it going? And I did a video on that thing about a year ago now, I think. And I did another little short video, vertical video thing showing the little grey box with the touch screen on it. And what it does, it sends data across LoRa to that unit, which then relays that same information directly to a web server on the Wi-Fi. So it's just a hopping point just to convert LoRa to Wi-Fi. That's what it's doing. But what I've had issues with is, as it sends data across the network, if the server stops responding, or that shouldn't, sometimes it will just freeze up for 20 seconds or so, and then carry on. I think I figured out what that is. The data would be hopping across, and it would lose it. So it'd go through, because I was using 2 devices on each LoRa network, and I think one device would be sending data through, try and connect to the server, server's busy, not responding, so the data's sitting there waiting to go, and then the other devices send data, overwriting the previous device's data, and it would replace it. So we actually lost information in that protocol. So I actually had to write code on the sending devices to recover from that. So if it detected that it hadn't got through, it would send it again. That was working fine, but it was a bit clunky. I didn't like that. So what I've actually done now is I've got it so that the data goes to the gateway. The gateway then has a buffer in it, so it just chews it all up. There's a cat trying to come in, which is going to be knocking on the cat flap forever. Hold on a second. Yeah, so the idea then it's got a buffer, so that way it just queues it all up, and as it comes in from the devices, it will queue it, and that way it doesn't lose anything. When the server comes back on, it then dumps the queue, and that sorts it out. So that's pretty good. So that's a little project we mean to do for a while, like a year, and I finally got around to doing it. I do have the 3D printer in the corner. You just can't see it behind a pile of test gear. See, that's a Solartron 7075. That's your 1062 HP 3457A, and it's just behind there. You can't quite see it, but it is there. The preview print is still there. In fact, no, the cat's. No, that's right. It's gone the other way. This cat is really old. It can barely even walk. That's why it knocks on a cat flap so we can let it in. My wife just did it just now. I'll show you something. On my desk, you see there's no 3D printer. Now we're talking about 3D printers. I've just built that yesterday. Well, last night. I haven't even I've turned it on, verify things move and heat up. That's as far as I've got. I haven't printed anything on it yet. So this is a new one. And what's special about this is it's been around for a couple of years now, so it's not completely new technology. But it's a dual filament 3D printer. So actually you can print 2 colours. So that's what's good about that one. That's just a review item from Banggood. Why did it hide that? Weird. Okay, Q, for some reason it held your message for review because it's got an icon on it. Weird. So that printer there is the G-Tech A20M. They also do an A20T, which has got 3 extruders on it. 3. So yeah, so it's been around for a couple of years, and there's reviews on them already online. A few people using them, and there's some known potential issues with them as well. Whether they've solved those issues or whether they just kept the design as is, I don't know. It's basically using an old version of Marlin, version 1, not version 2, which is fine, I suppose, but it would be nice to be different. But yeah, it's dual extruder, so it's got one nozzle, so the filament comes out the same place, so there's no alignment issues. It also means you can mix colours. If you've got 2 materials which are compatible, such as using two different colours of PLA, for example, you can actually mix them and create different colours, or you can blend between them, that sort of stuff. So things like that you can do with it. So that's going to be interesting. I'm doing a review on that thing. I've started recording footage on it yesterday, and I was building it. It took me ages to build it for some reason, and it's a really simple build. I don't know what took me so long. It's weird. I think it's because I was recording video at the same time and stopping and starting and getting interrupted, and and it's a bit hot as well. Wasn't motivated. Sometimes these review things I do, I'm not that motivated to do them. I want to do it. I'd just rather be doing something else. Yesterday I wanted to do something else, but I needed to get this done because it arrived about a week ago now. And yeah, I need to, get it processed, get it through the factory, as it were. So yeah, that's the something's coming up soon. I've recorded mailbag before it's showing up, and didn't show much in that one though. And yeah, it should be quite interesting. But it's not a bad looking printer. It's basically a clone of the Ender 3. In lots of ways, it's very similar. Let's do that one. Right, so it's very similar to Ender 3 in lots of ways. And there's the top dual spool holders. So two extruders up the top there, which you've got gear reductions on them. So it's got like a 3-to-1 reduction, which they say is to increase torque. Yeah, I'm not sure about that part. Anyway, yeah, it seemed like an awful lot of effort. Didn't really seem to need it, I think. But yeah, it's basically like an Ender 3 Pro, because it's got the horizontal platform there for the the y-axis. Yeah, y-axis. It's horizontal instead of vertical, so it's narrow, more stable. So, in many ways, it's very much like an Ender 3, but it's got a dual extruder, and it's got a slightly bigger build platform. It's 250 by 250 by 250. Oh, a whole bunch of comments. It was fun getting trouble with Gia. Hey, Metal Mickey, how's it going? Yeah, hey Peter. Yeah, the other thing I don't like about having a single nozzle in this way, it's a bit of a trade-off, is that it will mean you have to purge it, otherwise you get colour bleed. So sometimes you have to purge a lot. Keithley 195A. Oh yeah, cool. Not filling with that meter, but at least it's Keithley. Keithley is a good name, so that's always a good start. Even if it's an older one, it'd still be good. Yeah, it's got a decent fan in the front of it. That looks alright. So, can't complain there. Oh, it doesn't have the option to do currents. Well, AC volts. Oh, okay. Let me look that one up, because that's going to puzzle me somewhat. Here you go, on that video there. I sit there staring at the 3D printer all the time, do you? Let me just look that up. Keithley i5A, wasn't it? Let's look for a picture. Oh, okay. It's 5.5 digit. Let's have a close look. Which means getting closer to the screen in my case. There we go. Are those options? Because it does show amps and AC on the front panel. Are they options on it, or are they just not working? If I bet your handheld meters, yeah. Yeah. Mind you, you can get some nice handheld meters. I can't even say it. You can get some nice handheld meters these days. If I go back to there again, you can see I've got 2 meters sitting in the corner there. I've got they're both Bryman actually. One's the EEV blog, one of the newer ones. Well, the latest one, isn't it? What's the number on that thing? BM786. Got that one. I've also got this one here, which is, I've forgotten, A69S. I think that's a 50,000 count or 500,000 count meter. So that's pretty nice, and it's actually very accurate. So. But yeah, playing with those things. You can never have enough meters. You always need more meters. Even if you've got enough, you need more. Your person says no op. Okay. Oh, so they're optional features. That's a shame. Try getting an option now. Oh, okay, so someone's made a board to do it. Oh, yeah, cool. That's nice. It's always nice getting stuff which can be retrofitted in that way. Something I was going to do. What was that? There was a project I was going to work on. Same kind of vein. What was that? There was something I was going to do a retrofit board for. Oh, it's the Datron stuff. It's the Datrons. Hey Ian, how's it going? So I was thinking about doing the input sections, like the analog output, things like that. I was thinking about making boards for those, maybe. But then I was thinking, well, is there really much demand for them? Probably not. Like when my Datron display replacement, right? No one's inquired about those yet. I haven't really advertised it that much, but no one's inquired about those yet. I actually emailed Feedback Loop, Alexander, I think his name is. Pretty sure it is. Emailed him, seeing if he wanted one, but I haven't had a response. So either his email's out of date or he hasn't checked it or whatever, I'm guessing. But yeah, because I thought he might want one, because I know he had a Datron with a bad display which he tried replacing. Well, he did replace it, did it a couple of times, and then he ended up with a final version which was kind of okay. And the coffee's right here, Kristen. So, what I'm thinking about today, waffling on already for 15 minutes, I'm not going to do any more on a 3D printer today. We could, but the Y-axis is actually a bit noisy. I might have to just adjust the bearings a bit. I think they might be a bit too tight. When I move under power, it's fairly noisy. It's quite surprising. So I'm not going to do that. that we could have tried 3D printing live and see if it worked. I'm going to move that out of the way. What I'm looking at is either the Rohde 2101 Fluke counter, which has got a dead input. Trying to pull that apart and see if we can get anything on that. Or the Defpom 1062, which I've got sitting over there, which I think is going to be semi-boring. I think it's basically a capacitor replacement and alignment. I think that's basically what it's going to be doing. So I'm not too worried about doing a Defpom. I probably prefer not to really, because I don't think it's going to be particularly exciting. If at least I'm doing an edited video, I can compress it a little bit and make it a bit more paste. But I think in the Rohde 2101 Fluke account is what I'm thinking about looking at. What do you guys reckon? Live 3D print, trying to special analyzer. David, we've been there, done that. Yes, I hadn't forgotten. So, so what do you reckon? 3D print live with that thing potentially making a little bit of a noise. The print I'd like to do would take about half an hour plus setup. It's the idea is that when I did the Defpom displays, I did the enunciators section, right? And I had to do transparent and then black on top in order to make the actual enunciators. So what I ended up doing into 3 was I'd print transparent first, manually change the filament over, hopefully not nudge anything, and then do the black. And that worked out okay. But this printer should be able to do it automatically. So I've already made the model up for it. I'll show you actually. Let me get my Tinkercad up and I shall show you on the top screen. Let me get that up here. In your window. And we'll drop in a Tinkercad and I'll show you that. Because there's a certain way you have to do it. It's taken ages to load. I haven't dropped any packets yet, which has been really good on my stream. Nothing's been dropped, which is brilliant. Right, let's make sure I'm not leaking the information. Right, let's go to the top screen. I'll show you what I've been messing with when I finally click. There we go. So that's the original Defpom display. This board here, right? Can I make this bigger? Not really. Picture stays the same size. That's helpful. So let's open this up then. Hey Mina, Fred, 24 hours late. Alright, so there's the original display. I use Tinkercad, right? So it's just one block, and yeah, you can kind of see the thickness there. And I've got these recesses in the back for the LEDs to help diffuse them, and that's basically it, right? This was a guide for the printing, a block. So when it gets to that height, then it'd stop printing that and I go, oh right, now I need to start changing the colour over to do the black section, right? So that's what it was as a print guide. So that's the original one. And then what I've done is I've changed the bottom to be blocks. I'll open it anyway in case you can't really see it that well. But that is a bit loud. Hey Johnny, how's it going? And so that's the bottom. So I already had it in 2 sections anyway, so all I like to do is split it. So this bottom section will printed with 1 extruder. And then that's the top section. Oh, click on the right thing. And there's the top section there. Right, as you can see, it's got the holes through it for the text. Now normally you couldn't print this because you've got things like the floating bits in the centre of the characters, right? Which is why you had to do a transparent background first, and then the black on top of it. That way it's got something to sit on. which is why it's done that way. Okay. The thing I'm worried about with this particular printer is it's got a 0.4mm nozzle. On the end of 3 I was using a 0.2mm nozzle, and the tricky bit here is in this remote symbol. These two bits here for the M, they are very, very fine. I'm not sure how those are going to come out on this printer. I might need to use a smaller nozzle on it. So I did come with 2 spare nozzles, but I think they're both going to be 4mm, 0.4mm nozzles. Right. So that is, as you can see, is also floating. Right. So that gap is the same gap as the height of these. So these are 1.9mm. So it's got 1.9mm gap, which you probably can't see. That's the height of the characters. It's 0.5mm and 1.9mm gap. Right. I don't really know if it's necessary. It might not need that gap, but I've just left it in there thinking if it's 3D aspected in the Cura, it might matter. So it seemed to be fine. So then once you got that done, so that is extruder 2s. So right, so that's extruder 1, that's extruder 2, and then in Cura you merge them together. Now Cura is going to take ages to boot up. Cat toy is my phone. It's my phone. It's the squeaky toy is what I get for emails. It's email warning. Alright, so that's that stuff. And in Cura, when you import it, you can merge the models, and it will stack them together automatically. And it seems to, as you find where the points of the model are, where they match together, and it just merges them. And so if you do select all models, and then you do merge them, and it pops them together. And then you can tell it which extruder to use for each one. So that's what we're doing. Should I do that actually? Let's just make sure I pop it down here in case I accidentally leak information. I don't like to do that. Do stuff off screen. Did I miss any chat there? In Cura, print this walls. What do you mean print this walls, Peter? Because it's the first time I've done this whole dew filament thing, right? So I'm figuring this out. This is what I figured out yesterday, just from playing around. I could be getting something wrong, potentially. Let me just get these things up here. I'll just import them and I'll show you what I did. So let's drag those two there in. If I do it right, it'd be helpful. In there. And then I'll show the other one there too. Right. So there's models on the bed. Right, 2 individual models. So if I did select all and merge them, it shoves them together like that. So it detects where the parts are, right? And then you can tell it which extruder you want for each piece. You can do anyway. So yeah, I probably should have done it individually before I did that. Probably should have done actually. Let's undo that. Where's it gone? I've lost it now. I've broken it now. There it is. Let's do this. So that one there should be extruder 1. That's that one. And this one here should be extruder 2. Right, there we go. Now I'll do that again. There we go. Right, so you can actually see on screen here as well I've got it so it will display it at the same time. I've set the filaments up to be visualized as well. Alright, so clear than black. That's what I did anyway. If it's right, I don't know, but that's what I did. Alright, let's read the chat again. You can tell me how I'm doing it all wrong. Yeah, the 0.2 mil, obviously the 0.2 mil nozzle means you have to print a lot slower. But the detail is really good. It takes much longer to do the prints. But if you're trying to do precision stuff, then it's worth it. I don't think you can really go any lower than that without having lots of issues with clogs. Force symbols like the enter print. Ah, that's what you mean. Okay. What's that setting, do you know? We're looking at quality or shell? You've got line width 0.4. Maybe I should drop that down a bit. Shells. Probably can't see all that because I'm probably partially behind the window. Yeah. I'm not quite sure where it'd be. I mean, I don't know every setting in Cura. I mean, I haven't used it that much, to be honest. Show all the settings. Oh, it's in there, is it? Print theme walls. Did I? There you go. There it is. There. Print theme walls. Yeah. There we go. But what I might do then is reslice it. So 32 minutes, he reckons. Let's see. Okay. That's it done. Okay. We'll see if that does anything. But yeah. It's going to be interesting, you know, playing with that. Also wondering if I should maybe tell it to do like a different line width or something like that. I mean, those are these default settings. So I actually found that there's a printing profile in here. So these are the 3 printers I've got, in the 3V2 and now the G-Tech. Yeah, it'll print at 0.4mm wide though, yeah. But this means it will try and print them at least, yeah. Because you're limited by the nozzle size. So yeah, there's a profile in here for this printer. So that was good. So I just loaded that up. So it's using default settings because you have to start somewhere, right? So default settings, I'll try there, see how it goes, and tweak it from that point. I mean, the Ender 3 settings I'm using are very different to the original ones. I found I had to just tweak things. You know, I could get much more speed out of it. You know, my final settings in Ender 3 are actually very, very fast. So I'm basically printing up to, I think, it was in the V2, I was printing about 90mm a second or something on that thing. And the V3 I was doing, sorry, the version 1 I was thinking I was doing about 110mm a second or something. I could go to. But it depends on the filament using, temperature profiles. Basically, the faster you want to print, the more heat you need, because you need to melt the filament as it's going through the nozzle. So, I use a high heat and fast speed. But then if you want high quality, you'll need to back all that back down again. Otherwise, you get other issues. If you want, I can kind of say, if you want it looking nice, then you need to go slow. Yeah. So anyway, that's that stuff. 3D printing. So that's going to be a review video, and I'll show that thing going in the review when I get to that. Close it off. So, hey Chris, how's it going? Hey Ian, you still here? Oh, you popped up, said hello. Good to see you, mate. Chris, you're down the pub this time. I know you like to have a social life. Oh, mind you, I suppose the lockdown it's screwed that up, isn't it? Oh yeah, okay. Yeah, I just tweak. I'll just try and get. I don't know. I'll just play with it. Maybe it's because I'm using cheap filaments. I'm not using high quality filaments. I'm using stuff off AliExpress. So it probably takes a bit more care and fiddling to get it to work nice. But the 0.2mm nozzle works really well. But you have to be careful about clogs. Especially using high heats, like when I was doing the black on that one, the black tended to clog. The transparent was fine. The black tended to clog. Probably the additives on it. It's probably got carbon black in there, which is basically carbon, which is what makes it black. For those of you who don't know, I actually work in the plastics industry, so I actually have some plastics qualifications, including plastics materials. So, a bit of chemistry and rubbish like that. Anyway. Half I don't remember, but yeah. So, yeah, the black will have carbon black in it, which is granulated carbon, right? Well, very fine particles of it, like a dust. And yeah, that can cause clogging because it will build up. And on that particular nozzle, it did clog on the very first one when I did the first time on the Ender 3, using a 0.2mm nozzle on this two-step thing. I actually had it clogged, and I haven't unblocked it yet because I don't have anything to unblock a 0.2mm nozzle. I've got little probes, pokey things for the 0.4mm, nothing for the 0.2, and it's still blocked. So what I end up doing, because I've got a bunch of them, I just swap the nozzle out. And I'll worry about it later on. One day I'll get it unblocked. Maybe. I might not even bother. I might just chuck it out and get another one. Yeah. I the past couple of rolls of filament I've purchased have been branded Creality. So they're Creality branded spools. So they should be okay. Delamination stuff, yeah. Delamination. So you probably need a lot more heat. It's probably recycled material, which means it's got shorter molecular chains because of the properties of the polymers break down. So the longer the molecular chains, the stronger the material is. And to a point, if they're too long, then it becomes brittle. So it's a bit of a balance there between long chains and short chains, and it's usually a mixture of both, right? It's called the molecular weight, and there's a balance between both. And if you've got a mixture of long chains and short chains, you've got reasonable properties in there. But if materials get recycled, the process of recycling being heated and cooled, it breaks down the polymerization a little bit, and all the chains get shorter, and so you get different properties. And weakness of the material holding itself together as well as properties. It's probably E-Sun, yeah. Well, probably is, yeah. I don't actually know. But I was actually trying to find the filament properties in Cura yesterday. I thought, I'll go and see if I can find these Creality ones. And they're not listed at all, even on the manager thing. You got that manager, you can go in there and download them. And Creality isn't listed. So they obviously are reselling somebody else's material. I just don't know who. And E-Sun is possible, I guess. But who knows? It may even say it on the roll, actually. Let me find one of the rolls. This is going to bug me now. Where are we? So this one's actually labelled Creality on the spool. The spool's got Creality across it up here. That doesn't mean much though, because it's a logo and a tool, but just change the logo out takes about 30 seconds. But nowhere else does it say what brand it is apart from that. So it's a bit of a mystery. This one's a Creo Zone. Also got a K Camel. I don't know. Yeah. Itchy nose today. Right. Yeah, so, filament breaking, that's something I had last time, Chris. I've got a grey filament which I used. Used it quite a lot of stuff because the grey is actually quite nice. It's quite subtle, I suppose, as far as the effect of the grey. And as the spool got smaller, as I got down to, I'm probably about a quarter of a spool left. As it comes around to go into the extruder, even though I've modified mine so it's on the side instead of being up the top, so it doesn't come round sharply, it comes down more like this. But as the spool's got smaller, the angle's got steeper, and if it gets stressed or pulled even a little bit, it snaps off at the entry point. So that grey film I've got, I think, isn't a very good one. That's PLA, obviously. If it's a different filament, it might be alright. Where is it? There we go, this one here. So this is the spool I've got, this stuff. No branding on it. You see that? Maybe. Focus, you bugger. Of course it's not going to focus. Why would it want to focus? There you go. No branding on it. But this stuff is pretty bad for fracturing. Right? Didn't take much to break that. So, but PLA is not bad like that anyway. But yeah, I'll be finding that it's really touchy like that. It's doesn't like being stressed at all. PLA is great for printing, you know, it's easy to print with. PETG is slightly better, a bit tougher, but also harder to print. Hey, Anonymous Repair, how's it going? Yeah, so I'll be playing with that anyway, that'd be good. But it'd be interesting actually to see if I can do some copolymer work with this. We can mix two different PMAs together, two different polymers together. So I could maybe do PLA and PETG and see if they'll mix and see what happens. You can do stuff like that. You might find you can get the combined properties of both. You know, I might find that it's a bit easier to print and stronger, or you could find it just doesn't work and just falls apart. But no, you have to have materials which got a similar kind of base to them. But obviously PLA is a very different base to PETG. But you never know. Oh, okay. Add North. Right. I think I've heard of them. Think about buying one of those UV resin printers. Printing radio knobs. Oh, yeah. Lots of screen failures. Yeah, the thing is, anytime you got something which emits light of some kind, it will over time get weaker. So it may be fine for the first year, and then you might start having problems depending on how much you use it. Now LEDs get dimmer over time. You know, electroluminescent displays get dimmer over time, and I think they're LED, aren't they? I think they're LED backlights on those. Not sure. Screen is consumable. Yeah, so that's the thing. I mean, I was also thinking about getting one of those as well, those UV resin printers. If you're not doing much of them, I suppose they might be alright. If you're just doing your thing here or there, it might last a while. But I think you wouldn't want to do it all full, full on. you know, like a farm, you know. Hi Adam, how's it going? So yeah, I don't know, but I did actually get offered one once. What happened to that? Company did contact me asking to give me one, well, you know, to do a review on, and I said, yeah, okay, but I also need the other materials to go with it because I've got nothing, right? I need the curing system and, you know, the actual resin and that sort of stuff. And they never applied, so that didn't happen. They just wanted me to do their printer, nothing else. So I think that's what I'm presuming anyway. But as I don't have a setup for doing UV curing stuff, yeah, didn't happen. Yeah. So, right, just do something instead of sitting here waffling for an hour. Even put in 3 threads, yeah. Resolution's very impressive. That's what I like about the idea of those, is that you can do much better detail than you can on a FLM printer. FLM? FDM? FDM. FLM, what do I think of FLM for? Yeah, the smell's the problem, eh? Vapors, I mean, even these printers aren't great for that at times. I've done ABS on my Ender 3. Yeah, I've used ABS at work as well, so I know it can be quite smelly. So, yeah. You have to enclose it as well, if you can. Keep the ambient temperatures down, otherwise it creates so much warpage. Right, let's look at something on the bench instead of sitting here waffling. As good as have a chat as well. I didn't see BitLuna's video. Buying LCD photo plotting onto PCB material. Interesting idea. Would you get too much light bleed though? I don't know, maybe. I suppose you'd be right up there with no diffusion layers. Might work. 4K resolution. Wow. Hey Tim, how's it going? Yeah, well, I mean, you're going to get some kind of refraction and stuff in the actual filament, the resin. You're going to get some kind of refraction, so you're only going to get to a point where you get a point of diminishing returns, where you're not going to gain any more because of the refractions in the materials and even the screen itself and the tank. The screen is inside, you know, or below, so that layer there. Yeah, there's going to be something there, so it might be a problem. Right, let's get to the bench and we'll tinker with something. Let's try and fix something. Right. You want to move this out of the way? Like I said, I only got as far as powering up and testing things move around and heat up. That's as far as I got with it last night. I was hoping to actually finish the review, but I didn't get that far. So let's play with this. Bit of a beast, this one. It's pretty big. I can't see my screen over there, so I can't see what you guys can see. Now I have to make sure I don't forget to record video as well. Let's try and move things around so I can see. That might do it. And tip the mic around so it faces me, so it probably helps with the echoing as well. Yeah, record down a Fluke's account. So that's the plan, to look on this thing. So this is a 80 megahertz input and a 1300 megahertz input. And this one here is a 20 gigahertz input, and that one isn't working. So even, you know, as it is, it's up to 1300 megahertz, which is higher than anything I can generate anyway. I can't generate anything higher than that. I think the highest. What have I got? I've got my Rohde Schwarz here. I can do 2 gigahertz, I think. Up here, yeah, my Rohde Schwarz up CMU can do 2 gigahertz, I think. So, but generally I use my Marconi 2R22, which is 1 gigahertz. So I'm not going to demonstrate the problem again. Or should I? Because I need to record video. No, I think I'll just describe it. So let's get all the lights on. Get the camera fired up. I have to try and remember to do 2 things at once, which is always bad for me. 1 thing at once is like my limit. Not great at multitasking. Yeah, well, the normal counters are much shorter than this, so this one here is pretty big, alright? Now the normal counter is probably about that long, maybe about there. So that's about the length of the normal ones, the 1992s and stuff. But this one is obviously bigger because it's got a 20 gigahertz option on it. So it makes it a little bit different. Let's get my camera set up so I can record this thing. Oh, do you know what I haven't done? I should probably turn it on because I need it. There's a bit of a clue in a second, and Peter will know when he hears it. Because then Insidious Nixes. Yeah. That's my Nixie clock turning on. Just over here. I don't run it all the time. I only turn it on when I'm recording, basically, because I want to look after it and keep it going for as long as possible. If it's sitting there all the time, well, when I'm not looking at this area now or not sitting at this bench, then it's just going to burn the nixies out. They don't last forever. So I'll just turn it on when I'm going to be in this area, or recording stuff. So let's get my camera set slightly better. Still not quite right. Should I feed my camera in as well? I don't know, probably not. Probably don't need to. Now, I use manual focus on these things. Always recorded manual focus now. I did do autofocusing originally when I first started doing videos. It's a lazy way of doing it. But my camera would, because I'm so close to the camera's literally like here. The lens is just off screen from this one, right? But my fingers are touching it now, and it's it's only about a foot to this corner, so the depth of field is quite touchy. So if I moved around, the focusing would be shifting all the time. So that's why I do manual focus now. Right, I'll check the chat again, then we'll get started. Now, so I'll start recording video on it. Is it OCXO? Yes, it is. Yeah. Right. So you probably see my Dixie clock in the back of some of my videos. Usually mailbags, I think you'll probably see it. Oh yes, for those that haven't noticed yet, my mailbag videos, I've canned the mailbag channel. So I moved my mailbags onto that separate channel a few months ago, and I just wanted to give it a good go, see if it'll grow and if it will actually improve the performance of this channel. And it didn't, basically. So mailbag grew a little bit initially, then it basically stagnated. I was getting like 5 subscribers a week or something like that. It's pretty bad. And then, if that, I think it's actually a week where I got no subscribers. And in this channel, the hope then is that this content in this channel is less diluted, and so it'll get more consistent viewing, which will help to grow this one. Now, that may have happened slightly. It may have improved a little bit. But the loss in views from taking mailbag off was greater than the gain I was getting from having more focused content. So I gave it a few months to see if it would settle down and sort itself out. And it didn't work. So I brought mailbag back onto this channel. So the old channel will not, well, the mailbag channel, dedicated mailbag channel I should say, is not going to have any more content put on there. That'll be at. I'll just leave it sitting there. Maybe it will take off one day. Maybe. I doubt it. And I'll just bring it all back onto this channel and keep it all back on here, because I was hoping it would improve the performance of both channels, having dedicated content like that. It's more specific, but in theory it's supposed to work. It didn't. Don't listen to the experts. It's saying YouTube experts, do this. No, it didn't work. This is why you try these things. Alright, let's video this thing. Let's try and get a bit of this crotch camera. Actually, zoom this in, shall I? Can I zoom this in a bit? Or is that going to be too close? It might be too close in this context. Let's try this. Hold on. Get down a bit lower. What do you reckon? Maybe. Yeah. It kind of works. It's not great. I might just leave it like that, actually. That's a bit annoying though, isn't it? Having that in a V. Never satisfied with my camera shots. Never. There you go, let's do it. Let's get slightly closer instead. Okay. Let's check, and I'll go over there. You're glad I've been the other channel. What is that, Chris? You're seasick now. What's the weight of this thing? I can guess. Oh, it's probably about 5 kilos, I'd guess. Probably around that sort of value. Right, let's start recording some stuff. Let's get rid of this. Yet another detonator. Still tweaking my camera setting. I'll check the chat again. This time. Some electrons fell out. Yeah, it could be. Yeah, well, the idea was to try and focus the content so that this channel would have more repair-based or review-based stuff. I did want to split the review off as well, but the review wasn't really possible because I needed to get sure I've got enough base there to do the reviews. That's why I did create a review channel, but never put anything on it. So the idea was to try and get this channel focused on repairs, and basically that, right? And then the idea is to have a mailbag focused channel and a review based focused channel. And the theory being from YouTube experts that if you have a channel which is focused on one content, people tend to watch every single video, right? and that signals to YouTube apparently that it's a very focused channel, and people watch those videos, enjoy them, and watch them every time. So therefore, it recommends them more often to people and that sort of stuff. Right? The theory being that. And that makes sense. I've seen other channels like what's that channel called? Northridge Fix, right? He does very focused repair content. His channel's exploded in the past year. You know, a year ago, his channel was smaller than mine. He's got over 100,000 subs now because he's just doing repair after repair after repair after repair, and it also helps us doing consumer-based items, you know, games, consoles, and things like that, right? So, more general-purpose audience. So his channel's done really well. You know, really happy for him. Whereas my channel's just very slowly climbing, very slowly, but it's getting there. You know, I'm getting about 400. It's about 400 subs a month, something like that. I'm getting. So it's doing okay. Can't complain. 15,000 subs now, nearly, you know, approaching 16,000. So thank you everyone for watching. But yeah, so that's the theory behind it anyway. But what I found is that obviously because I've had less views on this channel, although I got more, this channel became more focused and I was getting gains from that, I was losing from not having mailbag on it. So it kind of balanced out. I didn't really gain anything by doing it. So brought the mailbag back. I thought I'll give it a few months, see how it goes. You know, no harm trying for 3 months. And I thought 3 months would be enough time for YouTube to balance itself out and readjust itself to figure out what's going on. I think it takes about a month normally for things to change. And I thought I'll give it 3 months just to be absolutely sure. And yep, it didn't work. So put it back. Right, let's record this thing. After I read the chat, one more time. Yeah, some people don't like mailbag, which is why I was trying to split it off. Stuck waiting on yesterday. No, I didn't. I said I was doing it in 24 hours time. I posted yesterday saying it's going to be 24 hours. And I announced it, well, I scheduled it on YouTube. YouTube scheduled it. Should have scheduled it for this morning, not yesterday morning. Oh, did it? Hold on a minute. It did. Had the wrong schedule date. That explains why the comments are there. Okay. Yeah, my mistake. I scheduled it for yesterday at the wrong time. Yeah, it's the thing. If you do a channel based upon pleasing people, then you're going to grow better, right? If you do stuff which people will generally be more interested in, it's going to do better. But I do stuff which I enjoy doing, right? Generally, there's a few things which I feature which are more laborious and work related, I suppose, or work type stuff rather than enjoyment type stuff. I do this stuff for fun, right? This is my hobby, so I record what I'm doing, to document what I'm doing. It shows other people the things that can go wrong with the bits of gear, and hopefully helps other people to fix their stuff as well. That's why I do it. But it also gives me a reference point as well. If I have a piece of gear which I think, I remember doing something about that particular fault, and I can go back and watch a video myself, and it will remind me what could have gone wrong as well. So it helps myself too. But although that said, I haven't actually had to do that yet, which was one of the reasons I started the channel. But or I started recording at least. But yeah, so I do. This is very much a niche, a very small niche. Try and do test gear stuff. Now, how many people are interested in test gear? Not that many. How many people are interested in repairing test gear? Far less than that. So my audience is naturally going to be very, very small compared to what it could be for my mainstream stuff. But I'm not going to sit out and do stuff I'm not really interested in. I'm not going to do games or anything like that. If I happen to get something across my bench which is a bit different, then I'll do it, basically. I mean, I've got potentially a PlayStation 1 to fix. It's been sitting on a table about a year now, waiting for me to actually look at it, but it's not something I'm really motivated to do. Anyway, it's a PlayStation 1. I don't really care about it, but anyway, it's not like it's mine. Right, let's read the chat one more time because I've been waffling too much. Waffle, waffle, waffle. Hang on. Oh, hang on, waiting. Oh, sorry guys, I screwed it up completely, didn't I? See if everyone buys the same crap, yeah. You to it, yes, right. Okay, stop waffling. On the bench, I have a record Dana 2101 frequency counter. Now this thing goes up to 20 gigahertz. Now I've got nothing which can generate frequency up that high, but I can test things, and I already have tested things. I'm not going to demonstrate it again right now, but I've actually verified that this input works. This input works. That's 80 megahertz. That's 1300 megahertz. Both of those work. The high frequency one does not work, and that is 500 megahertz to 20 gigahertz, and that one isn't working. I put a 1 gigahertz signal in there, which is definitely well within its range of of sensing, and nothing. Didn't sense at all. So we're going to pull this thing apart, and we're going to see if we can find what's wrong with it. How do we get into this thing? It's like 2 screws. I do like the design of these things. Do the right screwdriver again. Close enough. Right. So let's get into this thing. See what we find. I've already changed over to 240 volts. I think I did that in the live stream actually. I think I worked on this on a live stream previously. Just checked it out on the live stream. So if you're watching this video, which has been pre-recorded, then make sure you check out my live streams in future. Because this I'm also doing a live stream right now. There's no washer on that one. Was it stuck? No, there's no washer on that one. Only one of the screws had a washer on, so someone's been here before and lost the washer. Okay, remember how this thing comes apart. I haven't been inside this one yet. This is first time. Come on, slide off. It's getting stuck. Why is it getting stuck? Is it these side panel screw things? Yeah, it is. I can see that wiggling. Let's pop those out. They're getting in the way. These little grobbets. See if my spudger can do that bending. Here we go. That's better. Right. What have we got in here? Oh, there's a little diagram on the inside of it. Interesting. Module cable routing diagram. Curious. I wonder what I thought that needed to be in there. Now I was doing some visual comparisons. Because that is referring to these modules at the front here. So I checked to make sure they're right in case someone's messed it up. What do you reckon? Could be something that easy, couldn't it? I doubt it, but never know. Let's have a look. So it kind of tells you where they go, but these cables are really long. They're not exactly that easy to follow. So that goes there, that one goes there. So I'm just making sure. So the bottom one is going to the front terminal. Yes, that's correct. And the right hand ones, the top one comes to the front one. Interesting. Super long cables. Why is that long? Anyway, yeah, they're correct. They're wired up correctly. They should have the models in the correct places as well. So it should be PL6 at the top, PL8 on the bottom. That's what it's got marked there, and it's got PL6, PL8 there, so that's right. So it looks like those are at least connected up correctly. That rules that out. So the module which says you're connected up to is that box just there, which is on the input side. So where to start? That's the question. I was kind of hoping I could find something simple. Now it says you've got some markings on it too, so someone's definitely been here. Of course, there's a pen marks on this connector. So someone's had that off and made sure they put it back on correctly. Ooh. Previous repair attempt. That always makes me a little bit nervous. Just have a bit of a look, see if I can see anything else. Yeah. Just going to slide or not? I think they kind of do. I don't think I've got to take the feet off first. Just getting stuck. Yeah. I might take his feet off first. If I knew how to get the feet off. There's no screw in there. No, let's bend it instead then. Yeah, I did it. Okay, just flexed it a little bit. What's that rubbing on? There's like a rubber foot in the middle. It's rubbing on that. Yep, screws from the inside, so it has to slide out. Right. So I'm just going to remove this panel here. It's got like a rubber foot right in the middle here, which is resting against it, and it's not sliding very well. As you'd expect, a rubber foot is actually gripping. So I'm trying to flex it a little bit at the same time. There we go. We're out. Just want to do a visual inspection of the boards before I get too stuck into it as well. Wow. Okay. Some dodgy joints looking around here. Just like not enough solder on. Surprising. Looking for like rework and that sort of stuff. Anything burned. I think I did actually have a 1992, was it? Or 1991, and I'd had a bad component around here somewhere on that particular unit. Obviously, this is going to be completely different architecture, so it doesn't really apply. But I can see some wash marks over here, like flush box been rinsed off. It may be factory. It's like puddle. Or it's got wet. Looks like it's probably just washed off flux. There's a bit of residue left over. Potentially. I'll keep looking. Looking for clues. I actually wonder if this foot's supposed to be over here, because it looks like there's a square here, which is relatively clean. It's almost like it's been moved from here to here. Curious. Well, so far I'm not seeing anything. Just those joints which look like they don't have enough solder on. Yeah, that's like it's barely even soldered. There's quite a few of those actually in this area. Maybe just try resoldering it and see if it comes back to life. Might be that easy. Doubt it, but you never know. What's underneath that cover there? Let's have a look. Let's pull this cover off and find out what's underneath it. If there's anything interesting under there. Could be nothing. Just interesting to put a cover there. Could be just up reflections because of the high frequency stuff going on. That screw is shorter than the rest. So is that one. The two screws this end are shorter for some reason. Yep, small circuitry under there. That's plated as well. Just looking to see if I can see anything under here which looks burnt or damaged. There is nothing obvious. Seems as this is all the front end input from those modules, from that input we're trying to diagnose. There's one part here which is white, which I'm puzzled by, and it looks like it might be cracked. I'm going to feed in my camera input so you guys can see what I'm looking at. Make sure it's close enough. I'll have to get the microscope on it. Let's plug the HDMI in so you can see. I'll check the chat while I'm sitting over here. Oh, come on. That should be working. That should be working. Where are we? Here. Give me a second, let's sort this out. There we go. Right. That's for my camera. Check this chat again. Wow, I'm missing quite a bit. Here we go. Well, I'm missing quite a bit. Oh, lots to catch up with the chat. Well, give me a minute, guys. Right. Yes, IEEE 488 GPIB. Not like I've ever used it. I do have the gear to do it. I've got the adapters and stuff like that. Got the IEEE USB adapter. Never used it. I really need to get into that side of things. I've got no experience with it. Hey, Family Plans is going. Good to see you here. Thanks for joining us. And thanks for coming. Yeah, the holes are for a rack mount kit. You should have even hit 30 subs. Yeah, indeed. It's funny, when you're starting out, you think, oh, I've got 10 subs, yay! I've got 50 subs, yay! And 100 subs, yay! And each time they hit the next level, you know. It's pretty good, eh? Now 15,000, I thought I'd get here eventually, but yeah, it's a hard slog. This is why you have to do what you enjoy doing when you're trying to do YouTube stuff. You can't just do stuff to try and please people. You do what you enjoy. If you don't do that, you're not going to have fun. Yeah, that's what I was going to say to you, Ian. While I'm thinking about it, I was going to send you one of my voltage divider things. I was going to build you one and send it to you. I have to get around to that. I've got the parts now. The parts arrived, so I can do that. Lots of change to go through. Well. I'm not formally trained in electronics either, so I just picked stuff up over the past 30 years. No, more than that. I've been doing electronics for 40 years. Gives you an idea. I feel old now. 40 years, yeah. So it's about. Sorry, Adam, hear that? Your family having a few bereavements. Sad. This guy at work's lost a few people recently as well. He lost his mother 2 weeks ago, and he lost his nephew last week. Nephew was 5 months old. That's pretty sad. Right, here we go. Your 50,000 subs for free, never even tried. I'd love to know how you did that. Love to know how you did that. Okay, well, let's get back to it. So you guys can now see what this camera is seeing, alright? So let's try and get in closer. So right there in the middle of the board, there's a white component, and it looks almost like it's got a crack through it. It's quite interesting. Any idea what they are? Without having to look up the service manual. It could just be one of these, which is mounted upside down, but I'm not sure if it's cracked or if it's just artifacts on it, or whether it's something on issue or not. Don't know. Be able to see. So this is the part I was looking at, which sort of caught my eye because it's white and there's no markings on it, and it looks like it might be cracked. I'm not sure if there's a crack or not. Just trying to. Can you see that little line? That's no point with. Little line just there. I'm not sure if it is cracked or not. The question is, what are they? Are they capacitors? Are they special resistors? Don't know. Can you see that line? Right there. I'll have to look at the manual, see what it says it actually is. So, something has gone wrong somewhere. We've just got to find out what it is. It might not even be that. Opinions? This isn't 20 gigahertz, no, this is not. This is a mixed down circuitry. So we've got the very front end, which has been mixed, down mixed, and then it comes out of those. So it will feed a local IF into it, and then it will come back. But that is where it all feeds in and out, is over here. Alright, so if I flip it over, go the other way's out. So these are the processing sections, I suppose. There's the input over here. Let's get this camera a bit higher now. It's never right, is it? It's always in the wrong place. So, and I even try and focus it for you. How's that? So there's the input, goes into this box here. Right, that's got two connections on it, one at the front, one at the back, which go into these modules here. Right, they go into them. These modules also got some control circuitry and stuff through here, and then we've got 2 more connections down here which go to the board. They go to the board down there in the bottom, in that area, and that is what is coming up over here. So we've got connection there and connection here. Those are where those connections go to. So the actual input from that port comes into these sections here. I'm hoping it's on this board, not in the main modules, but you never know. Yeah, but in fact it's got some slightly dodgy soldering around here. I'll get it on camera. Being this close means it's hard to focus as well. Still, I'll focus if it'll sort me out for a while. I might go nuts. Tools are looking around here somewhere. Yeah, there's not much solder on those. Doesn't look so bad through here actually, but when I was looking at it with my naked eye, it was actually looking worse. So I was looking before at the solder joints on this board. So there's a few joints around which aren't looking great. This one here doesn't look quite right, and there's just looks like there's not enough solder on some of these joints over here and over here especially. There's a few there which don't look quite right. So it doesn't look so bad when I'm looking at it close up on camera though. But you see this joint here doesn't look like it's got enough solder on it, maybe. Yeah, I mean, I don't know if there's an issue with solder joints or not. I'd be surprised if something like this. But, yeah. I'm just suspicious about the solder joints. Still nothing obvious though. And in fact, it's basically working. That narrows it down somewhat. That's the OCXO at the back there. That's the OCXO in there. Metal box. Just looking to the side to see any capacitors and connections and stuff like that. Just in case something's come loose, you never know. So those flexes go underneath those modules there. I might lift those modules out. That's probably why they've got such long wires on them. It looks like I've got to take these screws here out. Those 4 screws. It's interesting, this side's countersunk, this side isn't. Because they've got it slotted to allow for movement in the frame, I suppose. To allow for it having manufacturing tolerances. There's also a socket down there, that's interesting. Right down there. There's an unpopulated SMB connector. That's for. It's unusual when I put something in there which isn't being used. Anyway. Check again. .1% resistors, okay. I think these are early 90s. Find a date stamp, yeah, okay. Serial number, date stamp 87. So it's 3rd of March 1987 on the GPIB board there. So there you go, late 80s. Chips, I don't know, so it's on 86, 85 on that one. So, but I'd base it on that anyway. It's when it's tested, so it's obviously when I actually assembled it. Let's pull this module out. So we're going to pull this module here out and let's have a look, see what's underneath it. It looks like the wires line up to actually do that. So I designed it that way, which is quite interesting. I was wondering why the wires are so long, but it looks like so you can get this out. I was trying to do physical inspection because a lot of the times I'll do a repair based purely on what I can visually see. Not always, but it's amazing how many times having a really good look over a piece of gear can find the problem. You know, there's some kind of clue somewhere. It says, you know, something's a bit burnt or a bit of discoloration, something like that. The amount of times that just doing a visual inspection will find the problem. See how long these wires. This flex is pretty good. Look at that, comes right out. Isn't that nice? So let's have a look around underneath here. And there's nothing that stands out there. Okay. Let's try and get a camera shot of this in here. So there is the module on the side. Yeah. ERA Technologies Sampler. You wanted to find that information out? Go on, focus. Focus, you bugger. Not on this. On that. Here we go. RDS 45B2. So, IF input, lower output. So, if I inject something into the front, I should see a signal on that jack there. In theory. Don't know what it will be. I have to look at the diagrams and service manual for that. But that would probably be the first point to check, is to see if we've got anything coming out of this box. Because there's nothing coming out of this box, there's a good chance I can't fix it anyway. But if it's after that point, I might have luck. Because these are just basically mixers. Let's pull this apart a little bit and have a look. So this one's marked as LO module, and that's marked as IF module. Well, you can't see what I'm talking about. There you go. Right, so bottom one there, PL8 is the LO module, local oscillator, and this is the IF module here. So they're both doing the down conversion, or use a part of down conversion. So we have to look at the manual and figure out exactly which bit's doing which, what's doing what. Obviously, so the LO is coming from here, so LO and IF. Well, IF is going from here. Make sure we've got the connections on there. So IF marked on there, and that's going through to the IF board, so that's probably correct. And so this cable here, I should be able to measure a frequency coming out of it. If I inject a signal, I should be able to see something on here, if it's working. I don't know what that frequency will be though, that's the thing, because it's being down converted. It could be a 10:1 ratio, something like that. I don't know what it will do. I'll have to look at it in manual, find it out. Should I get rid of some of this camera stuff off the screen? You don't need to see it. There you go. A little bit nicer, right? Adam, the high frequency input, the 20 gigahertz input isn't working. Yeah, I bet it was expensive. So I really need to look at the block diagram for this and figure out the layouts to try and eliminate things. Right, so let's find circuit diagram. How did I say that? Local oscillator will be the input to it. Possibly. No? Local oscillator should be the input and IF should be the output. I think. Yes, I guess. Let's look at the manual. Let's find a manual for this. I think I've got it already. I hope I have. I'm pretty sure I have. Record Dana. Let's find it. Record Dana folder. And 2101 service manual. That's what we want. I'm actually thinking I should probably move all of my service manual stuff to being on a server for people to access, because I've got loads of stuff here, stuff I've been collecting for years. What have we got here? We've got 156 items in this folder, and sometimes I've got subfolders with multiple items in. So I've probably got, well in excess of 200 manuals on here. User manuals, service manuals, that kind of stuff. So this is service manual. What are we looking for? We have a block diagram. See block diagram? Says how to use it. Should have probably looked at this before. Principle of operation, there we go, section 6. Must be in there somewhere. Let's try and find section 6. I was going whizzing past it, I saw it just then. Five. There we go, section 6. So I've done no research at all on this counter. I've got no idea. I just know general architectures of these things. I haven't actually researched this one at all. So this is what we're looking for, a block diagram. So input A, input B, input C. Right, input C is one which isn't working. A and B are working. Okay, is that big enough? Hopefully it's big enough for you guys to see. Yeah, well, I've already got I have several websites already, so I'm thinking I could probably put them on one of my websites or possibly make another website. I don't have a problem with hosting websites, it costs me nothing. I won't explain why. I can just go on your website. It only costs me its domain name, that's all it costs me. So 10 MHz reference goes into the local oscillator, which is controlled by a microprocessor. So it's obviously doing some kind of divider here, and the IF is the output, correct? And so there's an IF output here going to measurement system, and the IF is also going through the microprocessor. It's probably got some kind of divider ratio in there as well. It's probably doing some kind of what's the word for it? I've forgotten what it's called. There's a special kind of technique they use for this high frequency stuff. I've forgotten what it's called now. 5 MHz clock signal, you're looking. That's 5 MHz used for GPIB. You've got 10 MHz coming into the local oscillator. So we check that. But the fact that these other two inputs are working, I'm not too worried about that side of it. I imagine it's probably okay, because if this wasn't working properly, these wouldn't work either. Probably. I'm not going to say it's definitely right. But it could be passing through, being buffered or amplified or something, you don't know. So it could be that. There's no reason why we shouldn't check here. We also need to find out what frequencies we need to get here. So I need to find out the information about this local oscillator to find out what should be going into this module and what should be coming out. So then we can determine whether it's correct or not. I don't know, to be clear about the website stuff, I don't run a local web server. I know some people do run local web servers, if I could say it, it'd be correct. I don't run a local web server, it's all cloud hosted. So, I know some people do, I know that Ian does, I know he runs his own server, keeps his site on his own server. I think it relies on having a decent internet connection, that's the problem, and my internet connection is unreliable. So we need to find out about these bits. Right, local oscillator, sampling mixer, and IF. Those are the three bits I'm suspicious about. This part's probably okay because these are working. Right. So input B is using a prescaler, which is quite common. So let's see what we can find out. Input A, reference info. So that's channel A system, explains that one, which we know is working. This is input B, which we know is working. Channel C system, here we go. This is what we need to figure out. And there's a whole bunch of maths. I hate doing maths, I'm rubbish at it. Yeah, let's make it bigger so you can see. 5 MHz to 20 GHz, as we know. So sampling mixer down to intermediate frequency, which we know. Mix down to harmonic heterodyning. Here we go. That's what I was thinking of. Okay, here's got a mess. Come on, someone step in. If I'm injecting 1 GHz at that input, what's it going to be coming out? Who knows? That is completely lost me. It's not good for me. If I really wanted to, I suppose I could sit there and figure it out, but frequency 1 F1 minus frequency 1 F2 divided by local oscillator 1 minus local oscillator 2. Yeah, because it's obviously switching between frequencies to determine what it is. Yeah, this sounds like fun. So it uses harmonics. So it should sweep through until it detects a signal, then it should lock onto that, right? So that's what it should be doing. Which means I have to tap it off. I can't just interrupt it because I want to determine whether or not that part's working. Otherwise it'll just be sweeping continuously. So if I, mind you, if I see a sweeping signal, then I know it's not seeing anything. I think I do have some T-pieces and stuff like that for those SMB connectors to hook in. I think I've got some. FM tolerance, yeah. Set down for highest value. As soon as the IF detector detects a countable signal, low frequency sweep is stopped and a dead time starts, which allows the local oscillator to stabilise. Okay. Yeah, so this might be relevant. Right. IF bandwidth. Come on, tell me what Fluke is running on. Been helpful. Local oscillator module supplies a relatively high signal to this snuffling mixer. Good. The range is 292.5 to 354.5 megahertz. So we need to make sure that that signal is coming out, and it should be sweeping. Let's have a close look here. Yeah, that's what I'll be doing. I'll inject a signal into it and see what comes out. Yeah. Jason's electronics should be need a website building. Yeah, that's not. I don't do building for other people. I do my stuff. I just don't have time to do stuff for other people. That's algebra. Yeah. No numbers, yeah, well. Okay, so we've got a bit of information here. So now the local oscillator space between those ranges. So that's something we can verify, make sure that is working. And it does it in 100 kilohertz steps, interestingly. It's also using a VCO. What's this bit referencing? Local oscillator block. Okay, so this is that module itself, it looks like. 10 megahertz input. As we know, we knew that already. It's also very generalised block diagrams, but too generalised. I want a bit more information. Could be something in this chain, yeah, but it could be localised light output is by something in here. Could be localised fault as well. Could be power supply fault in the module itself. But I don't want to pull those apart unless I need to. What else can we look for? So go and find information about the output from that module, that sample, let's see what's supposed to come out. So this will be on that ribbon cable that feeds into it as well. My camera just turned off because I've been sitting here too long. Alright. There's a lot to consider here. So much stuff, I'm just glancing through it right now. I'm not actually reading a lot, I'm just seeing what things jump out at me. Sometimes that's just enough. IF processor is the next bit we need to look at. And there's the block from that. There's a mute input, that's interesting. You never know, could be that. Plus 7 dB plus 23 dB plus 23 dB. It's got a bit of gain in it. It's got a voltage reference, which is used to tell it when it's detecting a signal. So these are op amps. There's a SMET trigger. Could be something here. Could be in this section, the F&O, where it can't detect it. Yeah, okay. What IF is it being fed? It's got 175 MHz low pass filter. That's a clue. And a 200 MHz low pass filter. R2, was it 31 to 122? It's very low frequency output. I'd just like to know exactly what it's supposed to be putting out. And this measurement system stuff, which is beyond what we're looking at right now. So, below 200 MHz it looks like on the IF. So below 200 MHz at least, and it's like these other ones which actually narrow down lower than that, down to 31 to 122 bandpass filter. Because this doesn't say what the frequency input is, which is a shame, which it told us. It's going past low pass filters. It mentioned the highest frequency set was 200 MHz, so it's likely to be less than that. Right. Birds, yes. Of course, I've got the window open because it's summer here and it's awfully hot. Well, I can't see my temperature gauge right now, but probably about 27 degrees right now, I think. Those challenge cells, which is great. Let's start playing with this thing. Let's see what we can find out. Let's do the view there, and so I'll make this a little bigger, maybe. Let's go back to one of the very first diagrams in here, which I now have to find because I should memorise which board layout that was on, or which page number that was on. Where is it? Yeah. I wonder if I should just go to tee off the IF amplifier, see if there's anything coming out. In case that whole block there is okay. You need to start somewhere. Either start in the middle or start at the end. Those are my choices, really. That's the other one. Where's the main block again? There it is. So I've got to find my connectors and stuff and tap into this. Should we look at circuit diagrams? So that's on page 98. Remember that, page 98. Actually, let's just quickly go back and go into here again. So that's block diagrams is one thing. Let's look for circuit diagrams. Oh, a bit more information here. Go that way. This is diagnostic stuff. What's this bit used for? Hold on a second. Adapters, ribbon cable, trim tool. What's this team used to do? This might be helpful. So it wants to use a power sensor to measure the input level. Well, this is interesting. So SF41, SF37. Okay, what the hell is it? SF31, SF4137. This allows us to set a certain frequency for local oscillator. Calibration of the output. So if I can manually set the local oscillator frequency, that could be handy, but I need to figure out what the hell this SF41, SF37 are. I've got no idea. I'll have to start at the beginning. But so bear in mind, I can actually go back and manually set that, so if I need to do that, I can, once I figure out how to do these things. Are those switches? SF41, SF37 switches, maybe? So there's an adjustment there for setting the level. Right. You have clues in here, IF module. So it's got a lot of information about the actual module itself, which is great. That gives me some options. Right. So SF41, SF36. Ooh, this looks interesting. This configures the 201 to monitor and display the status of the IF bandwidth line from the IF processor module. So it's got some built-in diagnostic stuff which we can probably use, if I can figure out how to use it. And his IFs here. Interesting. Right. Very interesting. So there's a lot of detail in here, which is, well, a lot of detail. IF pass bands, level detector bandwidths, checking sensitivity. Again, there's more controls here. SF35, SF41. I need to find out what these SFs are. Let's have a look to chat. Must have been quite bad. Right. What was the dBm level? It was well within the range that it would accept. It does say the maximum levels and stuff on there, so it was fairly high. So it should have definitely detected it. I can't remember exactly what it was now, but it was high enough to detect it. It should have been. Input protection, fuses or emitters. Well, there could be. I want to try and get to the circuit diagrams and see where we get to. I'm just trying to absorb this information right now. With power limiter option 11 fitted. Okay, what is that? This doesn't have that, does it? I wonder what that is. Right. A whole bunch of other stuff. Right, so let's follow these diagrams. They'll be down here somewhere. There's just so much information here for things to check. It's incredible. This is way too much information to do a live stream. So let's just try and find where we can start, and we'll get started. Come on. Oh, God, let's make the window bigger. That's not what I'm trying to do. Now I can't see what I'm supposed to click. Right, here we go. And it's all here somewhere. I might start scrolling. That's nice. Right, this is not a great scan, looks of it. Kind of okay, but not the best. There's just so much on the sheet. So that goes to the IF module through here, 5 volt supply going in, plus or minus 5 volt looks like. That's probably all fine because the way the rest of it works. I'll be surprised if it's a power supply problem, unless it's something dedicated to those particular devices. It's 15 volt rail there. I mean, I should really check power supply, shouldn't I? Never know. Local oscillator's got 15 volts going to it. So what's this one here? That's the next section of the motherboard. Power supply stuff. It's a pretty messy diagram to try and follow actually. So what supplies we got? Minus 5.2, plus 5, plus 5, plus 5, plus 5. Interestingly, all from the same source. Fan power supply. Plus 15 volt from here. Op amp. Always suspicious about op amps. TP3. We can measure that, I suppose. If I can find TP3. Might take the GPRB board out to get that stuff. I can probably measure the connectors directly actually. Might be easier. And we've also got another plus and minus 5 volt rail here. Lots of power supplies. Display board. GPIB board. Come on, where are the modules? No interest in prescaler, it's not the bit I'm looking at. go. There's the IF board. Right. It's interesting, it's got this IF mute input, which is over here, which feeds through. I've lost it. Here we go. Through there, down to here. So it seems to shut this off here. Never know, it could be something like that. Oh, it's pretty small on your screen, it's pretty small on mine. And here's the local oscillator board, which is a bit simpler. Minus 5 volt rail there, plus 15 volt rail here, going to an op amp, or some kind of amp anyway, it's probably an op amp. Right. This one looks like it's fairly straightforward actually. Okay. Battery pack, yeah. Battery pack? How can you fit a battery in this thing? It's already pretty full. Curious. Right. Let's have a look. Catch up the chat. Yes. Is there a capacitor fault? I mean, it could be, you don't know. Right, let's have a look at this thing. Back to the normal desk view for the time being. So, there should be 15 volt power supply on one of these plugs. I should have paid attention to which one it was. It's that local oscillator one, wasn't it? Yeah, so that's the other one here. So I can probably pull that lead off and stick my probes in and find out if I've got a 15 volt rail there at least. Or I can measure on the bottom of the board. That'll be easier. Plug all this stuff back in again. Check the power supply first, make sure I've got those rails. If I can find the diagram again, and that's probably the best way of doing it, is check power supplies first, then we'll check the signals on here. These are screwed on SMAs, not SMB. There's an SMB down there. Not sure what the story is of this one here, it's a bit weird. Yeah, so there's only one SMB, and that is that's another input. That one there is from something else. That is the output, IF output on the back. There's an IF output on the back. Why didn't I notice that before? That could be handy. It might tell me what's going on. And the switches on the back are marked as A1 to A5. This is obviously GPIB stuff, because it's right by the GPIB connector. There's nothing but SF on there. Is there another switch in here somewhere? Anyone know what that SF means? There's another connector just down here. header thing, sideways header. There's another header in here. There's a few headers in here, it's quite interesting. And no switches that I can see. So yeah, SF. What does that mean? I don't know. Anyway, we can get down the connectors down the back here, so we can do voltage checks in this area. Is there something else I can do it with general power supply stuff? Sometimes it is, but I'll probably have to take the G5E board out to do that. Just trying to see if there's any markings. Doesn't appear to be. That would be too easy. Right. Well, we need to start somewhere. We haven't got very far so far, have we? There's a TP2 here on the post. There's TP1, TP2. TP3 was at 15 volt rail. Oh, there's another little post like that around somewhere with that voltage on it. Be nice if I can find it. Let's move this out of the way. There's nothing else here I need to reference, I don't think. Checking. Right. I don't see anything suspicious in the back here, at least. But unfortunately, I can't see that TP3. That would be nice to find. Right, I don't know. I need to get my head into this. My head's not focused. And I need to focus. So you've got the IF. If I hook onto the back port here, we can monitor that on a Fluke account and see what's coming out. But then I need to figure out how to tell it to lock that local oscillator. With that SF command thing, whatever that is. Perhaps if someone can look that up for me, or you can try and find it. It's in the manual somewhere. So let's power this thing up. And I need a BNC cable. I need two BNC cables. I need a BNC to SMA to go, well, SMA to in connector to do that one. And this is not going to reach my other Fluke account very well. That reaches better. So I have to use the higher frequency one. Hopefully it's in range. Also inject a signal. Let's see. Into SMA, no, I want into BNC. Here we go, into BNC. Go on, screw on. So I feel very rough. So there's a single input. first. If I shove in 1000 megahertz, no modulation, IF level has to be below 7 dBm. Yeah, below 7 dBm. So that's not the upper side on here, is it? What's the highest I can do? I think I can do 0. Anyway, let's do IF level 0 dB. That should be sensible. Should be able to sense that. So I've got my Philips counter set up on the right input. That's got power. We'll turn this on, and I'll change camera view so you can see what I'm doing. Well, kind of. You can get a kind of see what I'm doing. There. Let's have a look. Let's check the chat just to make sure I'm not missing anything you guys are telling me. Hey Christian, how's it going? Special function, yeah, could be. Right. You get in there, I'm just slowly getting there. You're here for Litro Boom stuff. Yeah, I don't tend to zap myself. Don't tend to. Can't promise it won't happen. Right. So as you can see, we've got a frequency on here. Of 0. And that is inputting 1 gigahertz at 0 dBm with no modulation input. So that should be demonstrating a usage, right? It should be working. So if I go to input B, actually I should make sure I've got the right input set, shouldn't I? It was on C, it's okay. Input B, and that is working, okay? So we've got a frequency coming on input B. I'm not worried about the accuracy of the frequency because obviously the overnight oscillator is still warming up, and so is my generator, all that sort of stuff. So it's all going to be drifting over the place right now. You know, drifting closer and closer, but it's not right. But you can see the input B is working. We know that already because I said it's already working. So chuck it back on input C, nothing there. And the IF is showing nothing. Let's just reduce my sample time because it's so long I can't really see what's going on. So the shortest sample time I can get, and it looks like it's jumping everywhere. So it probably is rotating through the sampling frequencies. So if we go to input B again, a bit on there, does that matter? No, it doesn't use that at all. So the IF is only on input C. Yeah, it's only active in input C, and I think it is just searching the whole time. It's just sampling, sampling, sampling. So There is an IF. It looks like it's within about the right ranges. Well, I say it was 292 to 350 something, wasn't it? 354. I'm seeing constant, like I'm seeing 2 flick up occasionally, and I'm seeing a lot of 300s, low 300s showing up. So it looks like the IF is working. From what I can see there, it's just constantly searching. And not finding anything. So that in itself is a little bit interesting. What I could potentially do is inject my own local oscillator frequency. Because if I do that, that would lock the IF, because the IF frequency should stay the same, because the local oscillator is not changing. Possibly. What's the SF thing? Where's the SF bloody thing? Come on. I need that, I think. Okay. Try low high frequency. Yeah, I can do that. That's not a bad idea. I'm doing 1 gigahertz right now. That's as high as I can go on this particular unit. Let's go down to 500 megahertz, which is supposed to be the bottom end of that thing. Megahertz. And the IF is now not rolling. IF isn't doing anything. So it probably means if the IF is working, maybe it's detecting something. Let's do 600 megahertz. Yeah, IF is rolling again. And that's sitting in the 200 megahertz range the whole time. So it looks like it is trying to do something. Because that is changing depending on what the frequency is. That's interesting. Okay, 800 megahertz. IF isn't rolling, it's just sitting at 0. 850 megahertz. Rolling at 0. 900 megahertz. Sitting at 0. 950. That started rolling around. So it is detecting an input because it is reacting to the input. Okay. That is curious. What do I make from this? So at 950 megahertz, I'm seeing a frequency rolling from basically 0. Let me change my input on my counter here. Gives me a bit of better resolution. I'm seeing like a 26 megahertz ish frequency there. At 950. 1 megahertz, sorry, 1 gigahertz, I'm seeing 29 again. It's not as reactive on this particular channel. Let's try changing filtering. I think it's just scanning around so quickly, it's not really doing it. I'm unsure actually. I'm getting different results. But using different input frequency, input on my frequency counter, which is interesting. It might be because it's going out of range. It's probably not giving the correct frequencies on there. It certainly goes to 120 megahertz. This looks like it's going to be less than that, but okay. So this goes 100 megahertz to 1.5 gigahertz on this input. So it might be going out of range of my counter. It might be the best input for it. It's probably why I'm seeing this nonsense on the screen. Could be looping out of range, that's why it's saying 0. But there is activity and it is reacting to the fact there's a signal. So it means there must be something passing out of the IF. But it's not locking on. It's curious. What I might need to do is get a spectrum analyzer on it. Let's fire that up. That might be more appropriate. I suppose my cable's going to be short as well, isn't it? Well, it barely does it. Just about reaches. It'll take a little while to boot up. Check while I'm waiting. Okay. Oh look, David, you said the same thing I just did. Spectrum analyzer. Good thinking. So the spectrum analyzer will definitely show up a lot better. I could probably even do a peak search on it if I can be able to do it. This is the CMU200 is not the easiest thing to use for the spectrum analyzer action. It's not the best. The old HP one I've got, which is in the other room, is better for that. But anyway, we'll get it going. Let's set the spectrum up, and I'll come and move the camera in a second. I'll show you what I'm doing once I really bloody use this thing. Start frequency. Let's go 0. Well, lowest I can do is 10 meg, isn't it? So 10 meg. And stop frequency 350. That'll be fine. Interesting seeing some spikes. Curious. So let's get the camera around. I'll move my chair out of the way. Yeah, you get seasick again. Hopefully my wires reach. You get the feeling you're getting taller. It's going to be very wobbly right here, it's any problem. Let's try and get this a bit better. Okay, that's what we're seeing right now, which is interesting. .155 megahertz. It's actually scanning. It looks too solid. I think that's right. See if it changes. It does change, okay. I might have the peak hole things on there somehow, if I'm going to do it. That's 500 megahertz there. So it is indeed locking and doing something. I'll do 600. Or something's just passing straight through. Yeah, that's on that peak hole thing. No, remember how to turn that off. I don't know how to do this. that's refreshed it at least. I don't know what the bloody setting is on it. It took me ages to find the setting, and now I can't find it again because I don't know where it is. It's not under there. Just now you can see it scanning. Alright, that's 700 megahertz. 1 gigahertz again. So I'll just change the resolution bandwidth, it resamples and it gets rid of it, so that'll do for now. So I can figure out what that setting is. So 1 gigahertz, it's 155 megahertz. And my camera shut off. It does that if I don't do it for anything. Yeah, you could be right there, Tim, but I'm getting something coming out of it, and that's something. So if I unplug the cable from the front, so there's no input. I always check the. So it's definitely outputting something. So it's reacting to the fact there's an input. Right, so that is actually working in that way. So I'll put in 500 megahertz again. I'll change the resolution bandwidth again, just to refresh it. And do a new peak. It's 114 megahertz. So 140 megahertz to 155 megahertz. That's 41 megahertz for 400 megahertz difference, well 500 megahertz difference, which is curious. I'll do 750 and refresh it again. And at 750 it's doing that. It's a whole bunch of harmonics. I don't know, this isn't really telling me much, is it? Apart from the fact that there is an IF output. This is at 300 megahertz. Highest peak there is 85. Well, it's reacting to it, that's something. But is it right? No bloody idea. Yeah, not too helpful. Apart from the fact we know we've got an IF output. So I suppose I could try and tap into the local oscillator output and see what's going on there. And verify that's actually working. I've got to find my connectors and stuff. And there's my generator and stuff up here. Here we go. So Marconi there, and that's what I was measuring on before, which didn't really tell me much. It was jumping around all over the place. It's probably because of the harmonics. I didn't really know which ones to log onto, because there was a lot of harmonics in it, so that's probably why it's jumping around. So, what to do now? Let's try and find my adapters and stuff, because I have to keep these in a different box. All kinds of bits in here. Got some SMA cables and a bunch of iPhone stuff. I'm going to go over that. do have some SMB adapters as well, so I've got that. I'm probably going to need an SMA. Where am I going to tap it from? If I tap it from the output of the local oscillator rather than from that, could use that maybe. Where's my other adapter? Do I have an SMA to B and C adapter? I do. That's helpful. Do I have a male version rather than a female one? I kind of do. Okay, this is even better. This works out better. This is exactly what I need. So I can use this one instead. What spanners does that need? Get those things off. That's the next question. Spanners. Oh, that was a good guess. 6mm. Right. So the output is that one there. And that is not the same, actually. That's not the same size. This is smaller. That is not the right one. I don't have connectors for that. The other end's the same size fittings. Why did I notice that before? They're not the right ones. I can't hook into these. But that's annoying. These are definitely different size. It's like a smaller version of it. Damn. This one I thought I had every connector possible. I don't have the right one. That's a bit of a hindrance. Because it means I can't tap into it. Well, first thing I've got to do is figure out what those connectors actually are. It's probably in a service manual somewhere. In the parts list, they probably list them. Yeah. SMC, you reckon? Possible? I don't know. I'll have to look into it. I've got SMB, which is like a plug-on one. I've got some of those. Obviously SMA. 3.5 months later they arrive. Yeah, that's the problem, isn't it? So it's a bit annoying that I can't just tap into it. That's definitely irritating. Come on, get rid of this again. Go on, get on the shelf. Let's got stuff in this box. There we go. And what do with that? No, whatever. Just get bored. Right. can't tap into the outputs. And yeah. Well, at least not that way. I can't tap into it that way. I don't know of any decent way of doing that. I could shove a probe in there and see if that will work. A oscilloscope probe, and hook that up. That might do the job. So now look at it. Yeah, I don't want to bend the pin that way because the pin's on this side. If it was a female socket, it would be a bit less worried, but it might be even the female side's tiny. I wouldn't want to risk bending that pin because that'd be a bit of a disaster. Yeah, I can't really tap into that, not without risking damaging it. That's annoying. Oh well, I guess there's some more stuff from mailbag then. I have to buy some more fillings. Alright. Next plan of attack then, because that one's ruined. So also got an IF coming out that's reacting to an input. So the sampler there must be working to some degree at least. It's giving a stable IF output. It's like a locked on. But is that an error or is that okay? It's not like it's drifting around. So that's curious. Right, what I think I need to do is revisit this and go back to the very output which goes to the main board, right? Let's backtrack quite a bit. Go back to the main board and think about what we should be getting at that point. So if we're injecting a signal on the main board from this channel C system, do we or don't we see a signal on the main board from the channel C system, right? Because if we don't see one at a point which makes sense, then we know it's before that point. If we do see one, then it's after that point. To try and just get some kind of ballpark area where it could possibly be. Now the IF in theory should be that point. In fact, we are getting an IF output, but is it right though? So we should also be getting a 10 MHz input on here, which should be on one of these. That's an output. That point there should be outputting. So IF is coming from that module, which we're seeing, and that one that goes down the back is this wire here from that point there. Is that right? No. I'm confusing myself now. This is terrible. I'm getting mixed up. I'm trying to think about too many things at once. IF module output. Or is that reference? I can't remember now. Goes down to PL37. Back to the diagram. Let's look at this again. I'm confusing myself. Top screen, chit chat. OD of SMC is about 3.7 mil. That looks about right. Yeah, so the genders are okay, not too worried about that part of it. It's just even on the female side of it, the hole is very small, so my oscilloscope probe won't fit into that hole, it's tiny. So the idea is, shove it in, get a decent connection. But it's tiny. I also need to be really careful not to damage any of this. So I'll just look at a different plan of attack, that's fine. So page 98 was the layout, wasn't it? Page 98. Because I've confused myself now, I'm losing myself. So 10 MHz going to LO IF output. So I need to look at this IF input to measurement system and figure out what we should be getting there, and if I can measure that to see if we're getting the right signal at that point. So we need to look at the main board, see where the IF input goes to, and see what we can measure there. And see if we're getting a frequency there which looks logical or not. So LO has 10 MHz going to it, IF has the main board connection. Right. Just trying to get my head straight again. And my camera's turned back off again, so I'm just going to go to this view here for the time being. So that's the output to the main board, which is just wire which goes down to PL37, so that's the output. And this one here is a 10 MHz input which goes down to the back. And we've got PL38 there, which is the IF output. So that's feeding through here. So unplug these things, try to yank on a wire. And my power cables got stuck. How did that happen? Right. So IF goes in there, comes out over here. Can I trace that through? So the connection goes to that capacitor there. This comes through these ones, so it comes up here to this line here. What is that line there? That line there is a chip. It's an AD96878D. And that's what that line there is. So I'm still suspicious about that white part there. Let's look at the circuit diagram to find out what that is, because that's directly across the input from that IF input. So the IF input comes in, it's got a 220 something, and then another one. So I need to find out what that is, because I'm just suspicious about it. It could well be a resistor which is upside down. It's entirely possible, but yeah, suspicious. Let's find the main board diagram. Where the hell was that? And that was, how many pages got? 275. 155, was it around there somewhere? I thought it said 155, come on. No, way past there. 200. Should have made note of that one, shouldn't I? Come on, where is it? IF input, there we go. Page 247, remember that number. IF input PL38, there we go. Got a capacitor. Enter sheet 3, that's helpful. Is that the right one? PL38, is that the right one? No, PL37. Hold on. PL38 is going down to the back. PL37 is going to that module, although they can't be mixed up, they're different connectors. I was thinking maybe someone swapped them over. No, it's not possible. PL37 we're looking for. That's my PL38. Oh, that's output. That's why. Input. Where are we? I might have gone past it. No. This side. Oh, we'll do bigger, not smaller. Previous sheet. No. Oh, I lost it now. Maybe I have. So PL37 right there. Where is it? Middle of the sheet somewhere, is it? Hopefully not. Must be another sheet. Okay, there they are. So this is like power supply stuff as well. A strange way to do it. PL30 is 10 megahertz on there. Another one. There you go. IF count. PL37. So 220 is 220. 22 ohms. That's the labeling they're using, not 220 ohms directly. So, and across the input, so it's a 27 ohm resistor. That's what that'll be. Okay, it might be upside down. And we have this device here, which is an AD. So I want to see where these disappear into the rest of the counting system. So I've got the IF input there. At some point these will all merge together. I want to find that point and work backwards. So sheet 4, so 17, 18, and directly to the components. That's helpful. So sheet 4, I guess this is sheet 4, is it? No, that's display. I guess figure 4 means sheet 4, does it? So IC8, IC8, IC9 ish. Let's look for those. Don't think it's that sheet. That doesn't make sense. That's why I'm having scans. You're not quite sure which page it's actually referencing. IC8, there you go. Sheet 3. And IC9 to sheet 3, there we go. So this is where the IF comes in, as to here. Which then joins onto here, goes into this chip. As a pair. Is that flip-flop? You also got this other input over here. It's got a few inputs. What's that one go to? Something output. Hold on. Output from here, which is pre-scaler. Okay. Right, so pre-scaler will be channel B. Channel A, channel C. Sorry, channel C, channel A. So interesting layout. So what on earth is IC8? Well, obviously from here it should be basically working because the other two channels are working. So I think this part onwards is fine. So maybe this IC9, negative 5 volt power supply. What's this one got? 5 volt supply, negative 5 volt supply. So that's probably working. My that's a pull down. Plus 5 volts, minus 5 volt pull down. Minus 5 volt rail. Yeah, so the minus 5 volt rail must be working because otherwise actually probably working probably. So I think that rules that out. But IC9A, what's the other half? IC9B, which is from the pre-scaler. So the chip's not going to be totally dead because that's working. Alright, let's have a look. It should be 270, yes, I should be able to measure 27 ohms across that. Yeah, that's what I was going to do. David, let's check that resistance. That'll at least eliminate that part. I mean, as it's only across the input, it probably doesn't matter anyway if it does go open circuit. I thought it wouldn't matter. Just to be sure. This doesn't look right, you know. Let's just quickly check this and I'll come back. Where are we? Here we go, right there. It's 27 ohms. So that's fine. Nothing wrong with that after all. But at least we know. Okay, So what the hell is IC9? Page 247 we're on. Okay, remember that, 247. I've got to find the parts list for this board now. There's pages and pages of it. Where is it? Go on, some 10 more pages on. Is this the right one? GPOB, no. Probably weren't going backwards, you don't quite know which board you're on. Come on. Oh, main board, here we go, this one we want. So IC9. There's a MC10231. IC10231, never heard of it. IC, MC. God. Dual Type D master slave flip flop, apparently. So yes, flip flop. My interpretation of that was correct. This means you'd be doing a pulsed output. Let's put in a data sheet up. It'll load eventually. Great O window. That's not what I was looking for. Where are you? That's supposed to be a data sheet. It wasn't. It's going to a web page, not that bloody device. This isn't bow roll, is it? I'm trouble finding a bloody data sheet for it. PDF. Back to the same one again. Oh, it's like not one of these other sites which are full of adverts. See what comes up. Come on, hurry up. Slow, very slow. Waiting for it to load. Right. Now, can I grab the data sheet? Yes, I can. That's better. Right, now pop that out. And I'll save this data sheet because it's always nice to save data sheets when you get them. So then I'll show you guys what I'm looking at. There we go. So not too exciting. general specific stuff. Doesn't say much, just flip flop. So how's that hooked up? $247. So we got that pin 6 there coming in. CE1 coming into that. And we got pin 7 is hooked up to pin, was feedback back in from the Q. Is that pin 8? Can't see what it says. So 1, 2. Is that 3 there? What's that one? Oh, that's helpful. Well, that must be 3, because we've got Q1 and Q1 bar there. So Q1 bar, that must be 3. That must be 1, 2, 3. Alright, so pin 1 is obviously supply. So it's negative rails tied to, and it's got a minus 5 volt rail supply. Okay. So pin 7 feeding back from pin 3. Pin 7 is D1. Pin 4 and whatever that is. So that is behind my head, so you probably can't see it too well. There we go, just like that. Pin 4 is R1, whatever the hell that is, was not used. Negative supply, VE, pin 8, that's pin 8. Don't know what that is. So we've got all the ones down left side, all the twos down the right side. You've got CC. Don't know what CC does. Anyway, so flip flop. Yeah, I mean, I don't know. I can measure there, I suppose, to see if that's working, see if it's doing anything. And that'll maybe give us a clue whether it's got an input and output. So we need to find that IC9. Right. Okay. Chat. Right. Haven't made much progress with this so far. This is pretty bad. So RC9, let's find a board layout. So tell us what it is on the board layout. Because it's only just up here somewhere. Seriously, where is it? IC9 down the side here, underneath the GPIB board, because that's really convenient. But at least I can get to the back of the pins at least, because it's through hole. So pin 1 is towards the centre, middle rear, pin 1. Okay, so I can find that chip. I'm just trying to see if I can see it on the board. outside that one. Yeah, okay, I can see it on the board from here, so I know where to look. Right. Where are we? That diagram. No, I've lost the sheet I was supposed to be on. 247, wasn't it? 247. Yeah. So I need to check pin 6 and 2 and 3 for activity. And we'll see what's going on there. See if it looks like it makes sense or not. Right. Let's change views to the camera again. Right, so let's make the camera back up. Okay. Hey Ray, how's it going? Well, it's a nice counter when I get to work. So what I might do actually is put these modules back in again so I have them floating around all the time. I don't think they're going to be in the way. Just worry about putting stress on all the cables and stuff like that, you know. I'll just put 2 screws in for the time being, just hold it down. So the chip is right there. Pin 2, 3 and 6 we're looking for. So 2, 4, let's mark this up so I can see it a bit easier, right? So you want this pin here, not that one, you want this pin here, that pin there, and that pin there. Right, so there's little blue marks let's put there. Those are the pins you want. So, do I use my oscilloscope to do this? I guess I should. Let's see what that comes up with first. I might need to use the spectrum analyzer. Just get a nice clip on one point. It's going to slip off and short out them AC power supply because that would be pretty horrendous. Don't trust it, it'll fall off. Can I clip onto here and still reach? Yes, I can. That'll do. Perfect. Out the way. Right, get onto that. I'll need an input signal. Turn it on. Turn power on. Put 1 gigahertz in. Make sure we've got the input set correctly. Otherwise we're wasting our time. Yes it is. Alright. So I'm check this and see if we get anything. There's something there. So I'm in the way and I can't see much. Let me just go to the scope. Let's change the views to the scope. That might be more interesting anyway. So this scope should be able to pick up those frequencies anyway, because this can do that. I've measured the bandwidth to 340 megahertz on this thing. This is my Hank scope. This came out originally with a 100 megahertz scope, but there were higher models which were software unlockable or something like that, I think it was. And or you had to buy a hardware version, I think. I can't remember. Anyway, I did a modification to it. Now it does 340 megahertz, so it's well within the range of the scope. And my probe keeps clipping off, which is why I wanted to move it. Get back on, stay there. What are we at? It's the 1 volt division, gives us a good starting point. It's been 6, so there's something there. Just tension that to it. That is sweeping. This was sweeping. No, it's not. And that's the output. And that's the other output, should basically be the same, and they are. So that's at least means they're probably okay. At least both the outputs are matching each other. No damage to it. AC coupling, yeah, that's all good. Turn that on. Yeah. There's a lot going on there, isn't there? There's a lot of harmonics in there. Yeah. But that is stable right now, which is interesting. Okay, so let's try and hold it on there whilst I change frequency. Let's do 900 megahertz. It changed. 500. And that changed again. But is that the same as the 1 gigahertz? No, it's different. Okay, so there's definitely something going on there. At that point, it's definitely changing there, so it's getting through to that point at least. But is it right? Let's move this into my spectrum analyzer. I should probably be recording this, shouldn't I? Never mind. Probe one of these pins with the spectrum analyzer. You won't be able to see this right now. I do have DC blocking on the spectrum analyzer already, so I don't have to worry about that part being a problem. So I'm seeing a weak signal there. Marker's peak as 159 megahertz with a 1 gigahertz input. If I change to 500 megahertz, I then get a peak at 114 megahertz, which is the same thing as getting a new IF output. So that matches up at least. And if I check the output of the flip-flop, then I'm getting 56.8 megahertz. So it matches up to that lower frequency. So it's halving it, which is what it should be doing. And if I go to 1 gigahertz, I'm getting about 79 megahertz. So yeah, that's halving. Okay. I'll check the other output. Yeah, that's the same. So that is basically confirms that flip-flop is working okay. That was it. Yeah, out the other way. I should know how to do that by now. Okay, chat. Yeah, the problem is this bloody manual's got so much information, trying to sort of skim through it in a live stream to actually interpret exactly what's going on and read it all and understand it. It's just too much to do during a live stream. It's probably going to be a few hours reading and interpreting. So IF is equal to the difference in the IF signal input frequency and the low signal's frequency. Yes, I agree with that. That is what I do know, but the question is the low signal is also changing. I need to figure out that SF thing. Where's that SF thing in here? SF41 or something, wasn't it? Yeah. Let's go right to the beginning, I think, of this section. Let's have a look. How do I change that setting? It must be listed in here somewhere. Set track. Is that it? Normal, automatic mode, manual mode. Maybe if I do manual mode, that will mean you're telling it what frequency it should be checking for. Is that right? So section 412 is what it looks like we need to be looking for. Oh, you can't see what I'm looking at. Top screen. Here we go. Let me make it bigger. So section 412 was what I was looking at just here. This section is what it's mentioning. So I think this set track maybe what I need to do, or manual mode. Don't know. Setting special function register. Here we go. Is that what it's SF special function? So 419 is probably where I need to go, is there as well. Yeah, so it's a mixture of both. It's a heterodyning as well, so it does multi-sampling effectively, I suppose. Yeah, 419. That's 412. There we go. This will be this bit for you. 419. Manual mode. I remember when I did my HP 5342A, I think it was. I think that's the number on it. That's also a heterodyning mixer, and I had to do this manual thing to try and tell it which range to be in, so I wasn't skipping across all the ranges. It's very similar to this in that way, in architecture. So shift megahertz store manual. Right, let's do that. Right. Shift is on. I should put the frequency in first, shouldn't I? Shift back off. Okay, so I want to do 1 gigahertz. So this is done as that's 90 gigahertz example. So yeah, okay, so 1000. 1. God, I've messed this up. Where's the 0 button not working? Oh, 0 is a bit dodgy. Let's reset. Okay. 1000. Shift. Megahertz, which is there. I didn't see it do anything. Store manual. Store manual. Where's manual? Yeah. Right. Don't know if I did anything. Let's do it again. $1,000. Shift. Megahertz. Store manual. Oh no, they don't look any different. Let's measure frequency. See if it's changed. No, you can't see what I'm doing right now. And marker, peak. That's 158 megahertz on pin 6. So if I change the frequency on that, that's still shifted. So I'll show you that didn't do anything, or I don't know. I don't even know if all these buttons are okay or not. I don't even know. That didn't seem to do a damn thing. Yeah, I don't know. That's probably doing the wrong thing. Okay. Let's carry on. Ratio stuff. So we're looking for, we're looking at 419 we're looking for. So what did I mention before? Was it 41 and 37, was it? Oh, SF. Is there an SF button? They're bloody well is, you know. There's an SF button on the front panel. Right. So that's how you get into those. So is it 41 allows setting of a low and harmonic number. 41 displays low detector line status. That's 37. So 41, then 37. So this is stuff I should be looking at, shouldn't I? Hey, this might help. Hi Mark, how's it going? So right, that's what we need to look at then. Does he go into more detail in here or not? Do we call them? I wonder if these special functions stick between power cycles. Probably don't. Okay. It doesn't say. Well, it makes you wonder, you know, if it is a special function, it sticks between power cycles. Maybe someone's done one and it's still there. Never know, because there's a thing here about disabling outputs. So it says they're retained whilst it's in a standby mode, but that's not the same as power cycling yet. So I don't know. So there's one here that says disables IF output under all conditions. So what I might do is start off by doing what's group 70? Is it all these other ones? It's not the same. Cancels all group 30. Here we go. Cancels all group 40. So maybe I should do this. Put code 30 in. Put code 40 in. Put code 70 in. Just in case there's something sitting there. Maybe it's not actually hardware failure. Just in case. So special function 30, 40, 70. And 50 is also 50 as well. So 30, 40, 50, 70. No, 60, interesting. So setting a special function register. Right. So first you have to enter into register and then enable it. Okay, so I have to do 30 shift store set or SF and so on. I'll do those and we'll see what happens. I'll be amazed if it works, but you never know. Let's put it down this way because it's less likely to touch something I shouldn't be touching. You know, like zapping myself, nothing like doing that. Let's put the camera out of the way a little bit so I can get in. Okay, so what was it was? 30. So 30. What? Why is it resetting when I'm pushing 30? Or pushing 3? Why is it doing that? Let's recycle. It's crashing when I push the 3 button. Isn't that curious? There we go. Right, so 30, shift, store, shift, store. Oh, it's crashed again. Oh, this is interesting. Is there a dodgy button? keeps on crashing. Wasn't doing this before. Let's power it down for a little while. Maybe it's an airflow problem through the unit. Maybe it's getting too hot in the back end because it can't flow through. We'll just turn it down for a little while, let it cool down. Just in case that's what it is. That's annoying. Figure out something to check. Because it probably needs to blow through the unit. Right, so yeah, we'll do that. So number, shift, store, SF. But if that's playing up, I might need to replace the buttons. You know, it shouldn't be crashing when I'm pushing buttons on the front panel. It could be coincidence, could be overheating. I'm not sure why it would, but it could be. Or I've got a bit loose connection. Maybe my power cable's a bit loose. That's a coincidence, maybe. Wasn't rebooting before. Input C is connected, yes. Yeah, okay, let's try again. Let's have a minute to cool down. Make sure it's everything plugged in properly. So, 30, shift, store, SF, okay. So that's that one. Now we need to do, was it shift FF, was it? SF. Maybe that's done it. So now to do 40, shift, store, special function, and then we do shift special function. I'm getting that right, aren't I? And then we'll do 50. I thought we've gotten shift, store, shift, store, special function, then shift special function. And then 70. Shift, store, special function. Operator error. I did it wrong. Seven zero. Shift, store, special function. And that's saying no. 70 is not appropriate apparently. Okay. Well, at least it should have cleared those registers out. And there's still nothing on input C. So it's not one of those. Special function light's still on. So let's do, was it 41? Yeah, it was 41, wasn't it? Shift, store, special function, 41. Whatever the hell that does. And 37, wasn't it? So shift, special function. And 37, shift, store, special function. Reset. It's showing a 1. That's supposed to be displaying the output, and it's showing nothing. That's curious. Okay. Change to 1 gigahertz. Still the same. That's interesting. In the meantime, I'll turn it back off. So what was that doing again? Let's make sure. So 41 allows setting of low and harmonic number, which I didn't do. I didn't set that. And 37 displays local oscillator detector line status. So 1. That doesn't tell me that much, does it? I might have to go back to that other section now. I figured out these SF number things. Yeah. So the input C is enabled. Now, where was that? So this, what page was that under? I don't know what page that was. Again. We have to find it again. We're on 61 right now. Let's go, was it section 6 something, wasn't it? Six. This might be just the description, isn't it? What did it say about changing those numbers? It wasn't that bad. That's page about 105 or so, wasn't it? Come on, where was it? Special functions in 713 for diagnostics. No, 713. It's going to be around here somewhere. 76. It's close. Right. These are 70 functions. And it's got a diagnostics chart here for fault correction. Oh look. Show us sideways. Does it mention input C on this section? AD check. This one here. Gate time selections. sort of turn my head sideways as well. Come on. Where's input C? Maybe this is a better way to go. Keep going. Doesn't look right. GPIB stuff? No, that's not helpful at all. Okay. Wasn't what I was looking for. This is where we were looking before. This is where we were. Okay. We found it at least. Right, so this point here, this is a critical thing. This is what we just did. We just did the 41 and 37. So 0 of it's in lock, 1 of it's out of lock. So it's got a header 1 display, which means out of lock. And that's with an input signal going into it. So what signal does it say to put into it? Hold on, does it say? I'm not hooking up this gear, I'm not doing power measurements of the actual signals internally. So probably out of lock probably means that because it is just free running. Trying to find a signal, possibly. So if I do this, that should change to 0. Okay, so let's do that then. So 55 shift megahertz store track. And I'll change the camera so you can see what I'm looking at. So does a special function retain from the previous time? No. Okay. So I have to do, what was it, 41 shift store special function. Right. And then got to do 37 shift store special function. Turn it on. Showing a 0 right now. Now it's showing as being in lock. Without doing anything. Alright, let's do this other thing anyway. We'll set this local oscillator to 325, so it's 325 shift megahertz store track. Oh, knocking things over. So 325 shift megahertz store and track. Still shows 0. Okay. Still shows 0 with or without signal. Okay. Let's measure the IF output. Let's see what's going on there. the analyzer up again. That's 145 megahertz right now, which is the first time I've seen that frequency. If I change the signal generator to 950, and it shifted as expected. So 950 megahertz, I'm getting 177. So 500 megahertz again. And that peaks at 114 again, so that's the same as before. Didn't really seem to change anything. But we're getting that one there now. When did that come on? Let's change the frequencies. 800 megahertz, still showing 1. 1 gigahertz, still showing 1. Well, this is surprisingly unhelpful, isn't it? It's a mystery. And you can't see that digit because it's off the screen. That's helpful, isn't it? There you go. You guys wouldn't be able to see it either. Hey Dave, how's it going? Well, this has been rather uneventful so far, isn't it? We haven't got very far. Yeah, I'm kind of confused by this. I need to think about this some more. It's being a little bit more involved to solve than I thought it would be. I was even just trying to figure out where to check. Because even this isn't really giving us reliable readings. It's a little bit odd. So this is for testing the local oscillator output and adjusting that. That's within the module itself. Okay, what I think I need to do is do that 325 megahertz thing, take off that connector, measure the frequency of the LO, because that should then be 325 megahertz. To at least verify that part of it is working correctly. Hey Helmet, how's it going? Label screen. Okay, interesting. So yeah, I think I need to verify each section. I mean, we're doing this for 3 hours now and we've got nowhere. It's terrible. So, yeah. Anyway, to explain what we're doing, it's a Recordana. So 20 gigahertz frequency counter. Right? Now, input A and input B, which are just at the bottom screen, they are working. That's the two smaller BNCs. And then the input C, which is the N connector, is not working. And that's what I'm trying to figure out. Yeah, LO output, what I could probably do, if I can set the frequency on that, say 325, that's within the bandwidth of my scope, so I can just use my scope probe, hook up my scope to it and see what's coming out. I'd be happy with that. My scope should be able to read the frequency and everything as well and see if there's any noise in it, that sort of stuff, so I'll be able to do that. But I'm going to have to probe on very carefully because it's got the little pin in there. So that's what I'm going to have to do. So let's do that and see what happens. Shut this off again for the time being. I have to put those codes back in again after. Which one's it? LO again? LO is the bottom one, so yeah, you've got to take it out. So the LO output is what goes over to here. So that is always crossed over. So that one there I've got to take off. Where's my spanner gone? Back to where we started out. I don't know, was it an hour and a half ago? Back to this. Right. I'll untangle these while I've got the thing off, maybe. Not although they cross over. Anyway. So I've got to probe it really carefully. I've got to be careful not to bend that pin, so I have to be very careful. So I'm going to have to put those codes back in again. Try and clip onto there. What's that? It's about 6 volts. 6 volts peak to peak is the output there. So yeah, definitely high level. So I need to get this thing to generate that output again, so I don't know if I can just do that. Don't think I can I? So let's do that again. 41, 37, what am I at? 41. 41, shift, store, SF, enable it, I guess. And then 37, shift, store, FF. SF, that's showing 0. Okay, and then was it 325? 325. I've lost the page now, haven't I? What the hell was it? 325. With a shift megahertz store track. I think that's what it was, wasn't it? And let's probe in there very carefully. And I'm getting a jittery 335 megahertz signal. Could this be my triggering? So there's definitely some amplitude shifts there. It's shifting amplitude. Hope you guys can't see it. You see that waveform there? So that's what's coming out of it. What am I looking for? No. Yeah, just open. Okay. That's saying 250 megahertz. As I'm adjusting my trigger level, the waveform's changing. Interestingly. And that's saying 20 megahertz. And that doesn't seem right, does it? I'm missing something here. Hey, Peter. Where do I get these auction bargains? Well, I don't really get auction bargains. I buy broken things, and they're not always bargains. Sometimes they're a lot of money, even if something's broken. Like I could pay $200 for a piece of test gear, and I'll have to pay $300 or $400 to post it to me. So not always a bargain, and even then there's no guarantee I can fix it. So eBay is where I go anyway. That's where I get my stuff from. But it's getting harder and harder to find decent stuff for the right price. Do I think I could have two issues? It's always a possibility. Don't know. But that LO output wasn't what I was expecting to find. So, where are we? Up here somewhere. Yeah. Well, I did that right. So I should have been seeing 325 megahertz coming out. It could have been the frequency counter being weird on that counter. Let's do the same thing with the spectrum analyzer. Let's do it again. And I'll change cameras to show that as well, if I can. I might get the back of my head or something. Oh. Let's just get it set up. Give me a minute. Back the screen up. Change this over. And I have to turn the camera on too, otherwise it won't work. Let's turn the camera back on. We'll be there in a second. It's all wonky because, you know, everyone likes wonky, don't they? So it doesn't help the heat in this room having all this gear turned on. Let's see if I can get this up here. And let's just do this to refresh the bloody display, get rid of that rubbish. Now I've got to do these signals. Put these codes back in again. So, now I've forgotten how to do the codes. Oh, come on. '41 shift special function. Right. No. No. How did I forget to do it already? 41. Shift, manual. Is that it? No. Oh, come on. How did I do those special functions before? I've forgotten to do it again. Oh, for God's sake. How many times have I done it? I've forgotten it. (41) Shift SF. Right. Is that right? No. Oh, for God's sake, I forgot how to do it. I got just special functions, I've forgotten. Oh, dear. Come on. How can I forget to do this? What page is that on again? Oh. Special functions. It was 713, wasn't it? So 173 we want to go back to it. Right. Shift store. Right, there we go. Shift store. Bloody hell. Right. 41. Shift store special function. There we go. And then 37. Shift store special function. And then I want to do 325. 325. Oops, that's 385, isn't it right? Yeah, 325. Shift megahertz. Shift megahertz. Store track. Okay. And there's nothing there. Ready? Let's put a frequency into it. Oh, I see nothing in there. That's weird. Let's do this again. 325. Shift. Megahertz. Store. Track. There's nothing there. Why aren't I measuring anything? Weird. Let's go high frequency, just in case it's gone out of band. Start is 10 megahertz. That should be right. Oh, there we go. It's out of band. That's interesting. So let's get the marker, find out where that is. That's 386 megahertz. But that's not 325, is it? curious. Okay. Let's do this again. Let's do... I wonder if I can set 200 megahertz on it. So it's 386. If I do 225... It says operation error, so I can't do 225. Okay. Okay, let's do 300 then. Shift, megahertz, store, track. Okay, it's 300 megahertz. It's 25 megahertz lower. In theory. And there's nothing there. There it is. 386 again. It's in the same spot, that's why. That didn't shift. So despite setting the local oscillator frequency, in theory, it's not shifting. Either I'm doing it wrong, or that's where the problem is. If I disconnect the 1 gigahertz again, and do it again, yep, same, 386 megahertz. Right. Let's turn it back off. This end up being something silly. Yeah, it could be. So this says it sets the low frequency to 325 megahertz. And check the display read 0. Ah, hold on. I'm not doing that. I'm not getting this. Is it because I'm not inside the other mode? Am I doing this wrong? Okay. Because I'm still getting like all zeros on the screen. I think it's supposed to get up to 354. I think it was the maximum. I think. I was just looping. Let me check this again. I might have done something wrong. Okay, so 41, shift, store, special function. 37, shift, store, special function. Turn it on, showing 0 on display right now with no input. But input on there, still shows 0. Doesn't matter. Okay, so now we do 325. 325 shift, megahertz, store, track. That shows 0 on display. We'll measure the point here and see what we get. There, it shifted it. Okay, I might have been doing something wrong then. So let's get a marker, find out where that is. That's at 265 megahertz. Okay, that's not 325, is it? That's 60 megahertz out. So the first one was 60 megahertz high, this one's 60 megahertz low. Okay, shove the input on there again, that 1 gigahertz input. remeasure. Look at that. It's scanning. I guess it's got max hold on this thing right now, so it's just going to hold everything it finds. So that's it, that's what it did. So the peak there is 305. Oh, now I've lost it. Oh God, I've messed it up. Now I've messed up the display. What am I doing? What have I done to my bloody display now? Just set the reference point. Analyze the level. Bring it back down. Somehow I changed it. Because we really need that to happen. Just a zero, thereabouts. Doesn't matter much. Okay. So I'm a bit puzzled by that now because I'm not quite sure what to make of that because that wasn't what I was expecting. Plus 2 on dBm. I'm not getting that actually. That's a good point. Actually, if I got my probe set to 10 times, I might do. Yes, I do. So let's stick the probe back in there again. So you're minus 12. Minus 12. That's 30 dB down. Is that right though? Have I activated it correctly? Touch probably for a start would be helpful. Well, it's about minus 11.5 or so. Like that. And do it again. Yeah. Minus 10 dB. Depends on the bandwidth I'm seeing. It's changing the whole thing around. But yeah, it's definitely does seem to be down if it is supposed to be 22. Also curious. You see it's at 385 megahertz again there. Oh, you can't see what I'm doing. Because I've got to change the camera. Because I'm an idiot. And the camera just turned off anyway. Well, possibly, yeah. That could be something to do with it. It could be the local oscillator's got a bad stage. I mean, this is what it's telling us to read, is this. Yeah, well, it's the same, plus 22 dBm. That doesn't look right, does it? And the frequency is also way out of range in that case. I think you wouldn't get a 30 dBm swing from having that adjustment. It might be a failed output. It could still be that I'm doing something wrong, but the fact it does actually specify these various frequencies, then it should be that level across across all of them. Basically, it should be basically flat. Right? So I've got 386 megahertz at one point, and then 260 megahertz at the other point. Both of those are outside of that range. Is that why it's low? It's being filtered off. Could it be because the frequency synthesis is wrong? The lower output could be a symptom of the frequency being incorrect. Because it says it should be setting the frequency to 325 megahertz. Should I have a look inside the LO, you reckon? Let me just do some more playing around with this. I want to see if I can tell it to do some different frequencies and see if I can get that frequency to come up. So if I do 202 megahertz, right, which is one of the other ones that's listed here, I'll see what that does. And if I can get something which makes sense within that range, maybe we can then get the correct levels. It could be a power supply problem. We haven't verified power supplies yet. You know, we haven't actually done that. Against my rule of saying always check power supplies, I haven't done it. We kind of jumped into the RF side because the other stuff was working. The A-low had a minus 15 volt power supply rail, didn't it? It did. could it be a power supply problem? Would it be annoying if it was? The LO is, can't really show it on here, I don't think, no, you can't see that camera view. Down there. So, I've just got the SM, whatever the hell it is, connector on there, and I'm sticking the probe onto the pin inside the connector. That's what I'm doing. So it's a scope probe I'm using. Between 10 times and 1 time didn't seem to make any difference actually. I was changing it just now. So, not that. What was I thinking just now? Change the frequency. Right, change the frequency and we'll see if that changes it to something else. And go back to there this time and turn the camera back on again. Clear that because that's the old one. So let's do 292, wasn't it? 292. Shift, megahertz, store, track. Opera error. Okay. Why don't we do 292? Curious. No, let's try it again. Still says operator. So I can't do 292. Let's try a higher frequency. Do 350. It accepted that one. So that's 350 megahertz. Let's see what that goes into. That's weird. It's not what I'd expect. And that's 385 still. Hasn't changed. Could the LO be dead? Possibly. Right, I think we need to look at the LO a bit more. That's where I'm heading right now. Seems we can't get the same results as we're supposed to be getting. But like I said, it could be because I'm doing it wrong. Somehow. Fun. Yeah, 1 times, yeah. If you got a loading, yes. But 10 times it wasn't changing it. Yeah, I don't trust scope, but that's what I've got right now. I can't use any other kind of connection cables. That's what I can use. I've got another way of hooking up to it. So, yeah, I mean, I don't trust the level completely, but the frequency is wrong, and that also makes me suspicious that the frequency isn't what it should be doing. So, changing that input frequency as this find on this page here. Wouldn't let me do 295 though. This is the other interesting thing. Oh, 292. Ah, 292.5. Maybe that's why I was outside the range, maybe. But I've put in 350 now, which is allowed. So, but the frequency didn't change in the LO, which means the LO probably isn't working properly. Since everything else, we're doing these steps, and it's not doing it. So, yeah. The wife had me have a drink. That's nice of her. Right, let's turn this thing off. Let's pull the LO apart. Oh, no, let's not do that first. Let's measure voltages first. Let's see if we're getting a minus 5 volts, plus 5 volts, and a 15 volt rail. I think it's minus 15, wasn't it? We'll see if we get nice voltages on that connector on the back of the wall. If any of those are missing, we have something to look at. If they're all there, then it's going to be in the LO. Let's do that. Okay, so let's go back to this view here. This one. See that, can you? Looks like it. So to not touch anything around here because that's 240 volts. So, the connector that goes to LO was which one? LO is that one there. This one here. Can you see that? Kind of. Just want a ground. Anyone do? That'll probably work. Lots of interesting voltages in there. It's probably because digital signals pulsing up and down, so it's not actually detecting the level correctly. 3.3 volt. Don't think that's right, so 3.3 volt again. There's minus 5.4. Don't slip. 5.2. 15. So the voltages are there. So we've got the minus 5, plus 5, and the plus 15. So I might go back to the main board, double check that those are what's supposed to go into that module. But I think that's it, the 3 voltages that go to it. Yeah, first of all, I'm check voltages, yes, but the other inputs are working, so I was fairly confident it's all right. Ripple? Yeah, okay. Could check that. Let me just look at the main board diagram first. Come on, what page was that, people? I did try to remember. Told everyone to remember what it was. Is that one? No. But it's close. Here we go. So, plus 15 volt, plus 5 volts, minus 5.2. So they were slightly out. This is relative to chassis ground, I suppose. That's what I had used, anyway, chassis ground. So that's the voltage there. The rest of these digital lines. So it's not surprising the voltage didn't make much sense because obviously they're going to be pulsing them off. Okay. So power supply's there. I'll check the ripple before we pull it apart, just to be sure. But I think that's right. Pin 4 is this latching. LO latch enable. And there was that IF one as well, wasn't there? IF mute. That's pin 15 of that connector. That's the other thing I'm just curious about. Maybe the muting's turned on so it disables it. Anyway. But then there was IF coming out, so probably not. Oh, let's pull apart this module and see what we find, shall we? Because that's where my head's looking right now. these do. So we've got one there, that's 15-volt rail. Nothing really showing up there. Yeah. It looks fine. Ripple looks alright. At least preliminary checks anyway. Nothing obviously bad. We shut down some of this gear. Get rid of some of the noise and the heat. It's up to 28 degrees in here now. 28 and a half. Okay. I want to double check something. Yep, okay, that's fine. So let's get this out of here. These are not the right screws for the screwdriver. By getting the screws mixed up, let's move those around a little bit. That one's over there. Right, there's the module. Okay. Well, there's nothing obvious that I can see. Everything looks visually okay. I can't see anything that stands out as being a problem, at least. Which is always a shame, because it's always nice to find something that's just burned. I'm not quite sure where to start. Might go around and check some inductors and that sort of stuff to make sure that there's no problems with those, because I've had issues in the past on, what the hell was it on? It was an HP device. The 3, was it 4? An RF signal generator anyway had a bad inductor in it, which has killed the power supply within the board. I can't see anything on input C. I can't see anything there which would indicate a fuse, unless I take that module off. There's nothing obvious anyway. I mean, I've seen input protection on things before where it's been a front panel fuse and stuff like that. A648, that sounds about right. Yeah. So, it could have been an 8647. I think of an 8647 it was. Yes, there's nothing obvious I can see there as a fuse, at least externally. It could be within that sampler module, but it is reacting to signals though. Don't forget I was changing the signal and it was reacting to it. So there must be something getting through. Yeah. Okay, thanks Mark, catch you later. So you're actually able to latch the data into a buffer. I think that multimeter goes to 1 megahertz, it's not that. But if it's ripple from a DC supply, you expect it to be 100 hertz. If it's an AC ripple coming through, and this is some of the switch noise, but this is linear supply, it's not switch mode. So any noise comes through would be 100 hertz, maybe 50 hertz if it's got blown diodes. Okay, so let's find that board. It's around here somewhere. So that's the main board. GPIB, pre-scaler, IF, hello. Right. Hello, lash enable. So that's turning these things on and off for data. So obviously it's using a common bus for all the devices, for the various parts of the unit. So the IF and stuff is probably using the same data lines. And it's be latching as required for that particular data to control, in this case, a synthesizer on this board. So, a reference input. We never did check that reference input, did we? One of the very first things we talked about was that 10 megahertz reference. Would it be irritating if that's what it was? Do you think I should check that? Hey, Chris, how's it going? I should double check that, shouldn't I? My instinct is saying to double check it. There's a test point over here, TP1, which is doing something. There's a pre-scaler over here. So that's obviously sampling Hello off. Does that turn the prescaler on and off? Hello output, is that? Yeah. So VCS circuitry, loop gain. Five volts through the inductor here, that's worth checking. 15 volts through these ones, that's worth checking. There's a capacitor here, C17. That's definitely worth checking in case there's tantalum that's shorted out, you never know. Although it looks like it's probably an electric, might not be. 6.8 microfarad. Where's C17? Although frequency error probably wouldn't affect frequency, but it would affect amplification, in case that's what it is. C17. I can't see C17. Come on, it's on there. There it is. Over here. So these are these blue capacitors, which are a bit odd. I haven't seen that kind of capacitor before, so I'm not quite sure what it is. Yeah, I think I do need to roll that 10 MHz out, don't I? So I'm not sure if these capacitors, that's a C17. Let's find out what the C17 is. Let's find the parts listing for this board. So on page 258. Right. Let's find this parts listing. Going one direction again, am I? What does it say? It's C17. No. Chip electrolytic. It's an electrolytic cap. Curious. It's a weird format. I've never seen that before. Yeah, it could go down to the whole digital decoding side of things and make sure things are actually changing. I could definitely go down that route, depending how you want to pronounce it. Yeah. Are there any tantalums on here? The all electrolytics. That's a weird format. I've never seen like that before. All electrolytics. So they could be bad. Right, so it's 258, wasn't it? So it's 228 for the parts list. 259 you want, okay. So yeah, you've got these weird rectangular parts. It's odd, I've never seen those before. New one on me. Okay. So yeah, I think I should go back to the thing we talked about at the very beginning, at 10 MHz input, make sure that is definitely coming through. Right, I'll just check the end of that flex, or the coax. Make sure it's 10 MHz on there. Now at least we'll know for sure that's definitely getting that signal. There's one more thing ruled out. And then we have to look at what's going in here. I mean, is it a local power supply problem? Can I inject power supplies and measure stuff on the board? I could probably just turn the thing on. Can I plug it in, turn it on? The cable's long enough. And I can measure supply on these ICs and stuff like that. Do some verifications like that just to prove they're right. But this is obviously the PL section here, pre-scaling back. So that's probably a voltage control here. You've got varactor diodes here, so those are oscillator. So that's the actual oscillator section here. So that'd be a voltage coming through the 4.7 volt diode here. Amplifier, oscillator section. What's that one there doing? Local oscillator off. So that must be killing the power to the oscillator. So when this is enabled, that will be shunting across there to shunt the voltage on the oscillator to kill that supply. And then it's sampled here back into the pre-scaler, which is obviously then used for down mixing into the synthesizer, so the synthesizer can control that loop. Okay. They're not standard electrolytics, they're like a rectangular box. It's odd, I've never seen them before. It's a new design, I've never seen them. Well, new design on me, obviously it's an old design because it's from 1987. New one on me. Yeah. So they're all for local field. I'm saying we look now to see what these capacitors are, to see if they're likely. If a capacitor's stopped working, is it really going to have a big effect, or is it just supportive smoothing? So this chip here is obviously for decoupling, probably not too critical here. This is negative 5 volt rail supply smoothing, probably not too critical here. It's interesting, it's on the 10 MHz reference coming in there, that's weird. And it's got DC blocking as well, that's curious. Plus and minus. Weird setup. So that's making it float around a 0 point of about minus 2.6 volts. Weird. Okay. There's one here which might matter. On op amp. Power supply, no, won't matter. Not critical. Another power supply one here, not critical. Oscillator one here, probably not critical, but might matter. Another one here, as we looked at before. So even if they are bad, it shouldn't really affect the circuit, really. Not in this case. I mean, this supply should be well smoothed anyway at that point, when they even enter the board, so it's just supportive stuff. Right, let's check the 10 MHz to see what's going on there. We'll check that bit first to be sure that's okay, then we'll try and figure out something else. So that 10 MHz will be on this cable here. which you can't see because I haven't changed the camera shot. Because I'm an idiot. So it should be 10 megahertz on this cable here, and we'll verify that. Scope is still turned on. Let's just get the probe from the spectrum analyzer. Probably doesn't matter too much, just get it on there somewhere. Okay. Plugged in, right. So I'm 1 volt with division. There's nothing there. Okay. They're not getting into the connector far enough. I'm not seeing anything there. Don't tell me it's a missing 10 megahertz signal the entire time. I can't see a signal there. Right. That's interesting. Have I missed something really bloody obvious? I would have thought it would be 10 megahertz here. Seems the rest of it's working. Oh, Chris. Okay, catch that, mate. I didn't realise you're still there as well. So, have a good night. So, that's interesting. There's no 10 megahertz here. There should be. As you saw, maybe then going off. I'm kind of off screen again. I just did a 10 megahertz test, then it came up on the screen just to be sure that it can read its own 10 megahertz. It can read its own 10 megahertz. It can, but we know 10 megahertz reference is working, but it's not at that point. Why is it not here? Okay, 240. Is that too early? Whizzing past, come back. Right. Where is the 10 megahertz output? It's on here somewhere. Let's find it. External reference. Input. We're close. Got a whole bunch of power supply stuff in here as well. Why don't I see it? There's one of the headers, the battery pack option. Well, that's what explains that one does anyway. Right. Where is it? Where don't I see it? Where does it go? Ten megahertz standard output. Here on 19. Is that what I'm looking for? Here on 19. Main board goes back to the back here, so let's find that connector. I can't see exactly where it is, I can see kind of where it is. Let's try and find it. It is over here somewhere. Is that it? Just turn the power back on for now. Okay, it's underneath that side. It's going to 30. So yeah, right there, that's where the 10 megahertz comes out, or supposed to come out, so let's find that. I think that's what it said though, it said 19, so that's a different one. We'll see, yeah, it's not the best. Cable's plugged in, show again, it's a bit small. So that's the connector it goes to here. So the cable comes up here, plugs into that. It seems like it's in properly. I gave it a bit of a pull, didn't seem to move, so it's not falling out. Yeah, so PL30 is what we need to find. It's 31. Where is it? $28. It's 38. We know it's not like in the middle of a board diagram somewhere. Generally they're not, but sometimes they can be. Right, let's go to the next sheet. I thought it'd be close to this thing. There we go, it's PL30. Here it is. Right. So that comes down here. Here we go. IC4. Internal reference input. Amongst other things, and external reference input. So internal reference input should be there because it does work in other ranges. That is a bit curious. Why does that not work? That should be there. Pin 7 of the op amp, of the op amp. C85. Not sure what you're referencing now, I might have to go back. So right now I'm just looking at the other end of this coax here, so that should just work because the other line is going over here. There's a reference, internal reference. So the internal reference is working, right, because the other modes are working. But there's nothing other in that line. So I think we need to check between the connector, or ideally IC4 pin 7, as it looks here. Alright, so it's coming in here, well, coming out of here. Right, so that's, this one's internal reference, this one is the gigahertz reference, which is missing. So it's also going to be coming in here as well. So that one's there, this one's not. So what is IC4? Check the cable, yeah, so I'm thinking I'm going to check between the connector and the tip of the cable. Just in case. But I'm always suspicious about op amps because they fail so often. That's quite amazing. Older ones do anyway. Not so much new ones, but if they've been around for a while, in the older gear that I work on it, I've come across op amps bad many times. So I'm always suspicious about op amps. Anyway, so IC4. What page is that? God, I need to start making notes, don't I? Was it 173? No. Gotta find this page again now. What I'm looking for? IC4. IC4 is a MC10116. Another part I don't recognise. That can't be right. It's a triple line receiver. Really? It does not sound right. So pin 6 and pin 7 are outputs from pin 9 and pin 10. According to this. Got paid 248, wasn't it? Okay. Pin 9 and pin 10, pin 6 and pin 7. So yes, this looks like the right part. Okay. So I shall pop this out and show you this. So a triple line receiver. I've got no experience of these things. Never seen one before. So it's obviously got 3 sets of inputs and outputs, and it's using 9 and 10 as an input and 6 and 7 as the output. So one's working, the other one should probably be working too. Weird. Let's save that data sheet so we'll go for next time. Okay. So let's go back and check the cable, because maybe that's not got both outputs working. Maybe the IC4 is what's gone wrong. It's just odd. I thought if I got one, I should have two. Anyway, let's check this thing that way and change the camera view so you can see what I'm doing. Just turn the power off for the time being. Get less chance of electrocuting myself in. So it kind of connects between here and here. My other one, this one here, might be better suited to this one. Because I've got small probes on it already. Sounder, good enough. Shove that probe into there. Should definitely go into the connector. And then let's measure back to where the connector is, which is here. Whoa, the cable's okay. Well, let's have a look around this back area and see what I'm seeing. No signs of rework. Go straight to the chip from here to there. I don't know. Soldering would be better. Right, let's resolder it. Or should I check for frequency right there? Let's check for frequency right here. Just do that. Right, let's pull this probe off. It should be able to measure it without it. So. Getting plenty of noise because I don't have a ground connection right now. So pin 6 I have a 10 MHz signal. Pin 7 I have garbage. Let's show you this. So that's pin 6. Let's get a decent probe on there. Still a lot of noise and stuff in here, but don't think I've got my ground connection on there. So it is going to be a bit noisy and yuck. Alright, so that's 10 MHz. And pin 7. Nah. No good. I'm just generally probing around now, see what's around. Maybe I'll stick my ground probe on there just to pick up lots of noise. So that's 10 MHz coming in there, I think. What pin's that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. That's 9. That's 10. Yep, so signal coming in at 10. No signal on 9. Is that right? Uh, 9, no signal. Yeah, okay. So that is coming in from the internal reference input. Kind of. It's got a sampling thing coming on here. Or is it 8? It's 8. Okay. That's feedback from there. But there's a signal here anyway. So there's a signal there. There's a signal on 6 and garbage on 7. Now, as I'm not familiar with this particular part and how that works, I'm not sure what I should be getting here. That's not the right one. Let's see the other thing I was looking at before. Let's find it again. I think I closed it. Alright. Data sheets. You've got circuits. MC1 or something, wasn't it? 1011. This thing here. Oh, this thing here. So, how does this stuff work? Differential signals. Yeah, I don't know how these work. I've read it, but I don't understand it. Is that just going to be like a mirrored pair, opposing waveforms, so that, like, you know, one's going up, the other's going down in the waveform, you know, positive going versus negative going, so therefore they cancel each other out, any noise, or something like that? Is that right? I don't know. Go on, one of you guys must know. I better read the chat. Should we put a signal pin 6? That's what I thought. Thanks, Helmut. Thanks, Dave. I'll catch you next time. Agile called it. Yeah, so it does definitely look like 10 megahertz is missing. Yeah. So it's just using that as a buffer and splitter, I suppose, because it probably doesn't, the actual phase probably doesn't matter, because we one, you know, inverted phase in the other, and that's what I'm trying to say. So it looks like that could be the problem. How can I verify this? It's a strange way of doing it. I just don't understand why they've done it that way. Like, you've got the same device used for these 3 sections, and it's just each one is isolated. So it's pin 15 from that one, which is one of them. Pin 14 is not used. It's using 13. 12 is 12's not used. Is that 4 not used? 2. Yes, 2 is the output from there. No, that's the other way around. So they're inverting. And this is using both 7 and 6. So it's got that positive side drive. Apart from that one there, which is doing a look back. Yeah, okay. So I think this IC4 might be bad. Check for short and pin the ground. Okay, I will do that. The output should have complementary levels based on input differential being either positive or negative, difference between positive and negative input. Yeah, okay, right, I think I'll get you. And the signal's coming in this one. I don't know what that was doing, but yeah, signal's coming there. That is passively coupled. Not sure what the positives are doing here. So like a, I don't know. Is that? That's an output from this one feeding back into this junction here. Probably doesn't matter because it doesn't look like it's anything to do with that. I just want to expand my search a little bit. And these coming from here, which comes from this row here. Which is from external reference. So we're not using external reference. Well, if I put an external reference in it, it shouldn't really change anything. But you never know. Smooth average signal level. I'm thinking IC4 is bad. At the very beginning we talked about the 10 MHz signal. And then we didn't get back to it. Oh man. Okay. Is this rebooting? I think it's overheating again. Let's shut down. Okay, well, I need to turn it off anyway to check for shorts. Let's try not to rip everything apart. Can I? No. Alright. Let me check for shorts. I've got that pin, you have to see what I'm doing right now. Let's check for those working. So let's go between, let's find the pin again, I've lost it. Over here. So it goes from there to ground. There's no direct ground connection at least. There's no apparent shorts on the output of the chip. So there's not shorted. It might just be a blown output. Let's check the input of the board. See if the input of the board is what's shorted and it's then blown the chip. The input was which side? This side over here, I think. You can't see what I'm doing, I know, sorry. Try and get something certain. Oh, just probe onto the capacitor or something, I think. Is that hooked up to it? No, it's not. It's on the bottom side of the board. Of course it's not. No, the input of the local oscillator isn't shorted, so it's not like that's blown and blown that chip up, which is a suspicion. But okay, well, it looks like it's IC4. So what can I do to temporarily test this? If there's no short, do you think it's safe to bridge it to someone else? Yeah, I'm thinking about chucking an external reference on just to see if it's yeah, positive, smooth, negatives get the signals. Yeah, so I'm thinking about putting an external reference on just to see what happens in case it turns up. I don't think it will, but if the internal reference signal is too weak, maybe it's causing some issues with sensitivity. I ignored it for 3 hours. Yeah, you should have kept going. 10 megahertz, 10 megahertz, 10 megahertz. I'll blame you. Right, we'll see. Okay, well, I think we're on the right track though. I think this is where we're supposed to be going. I'm just wondering what I can do to try this. Do I risk injecting a signal in here? I mean, this chip I think is probably bad anyway. I mean, should I link across from 6 to 7 and see what the hell happens? Oh, it's 3 keeps hanging. Okay, I'm not dropping packets. That must be a YouTube thing. Yeah, again, trying to get the signal into it is the problem because of the connectors. Fortunately, I can't just shove another connector in there because I don't have the bloody right one. Okay. Right. We'll chuck an external reference in, see if anything changes. I'll plug everything back together. I think I can put that LO module back in again, eh? I don't think there's a problem on that board. Yeah. If I put the LO module back in again, reassemble that section, it does look like it's 10 megahertz problem. And can I inject 10 megahertz directly into that module without the LO? Into the LO module. It'd be a bit hacky, a bit of a hack. I could probably do it. I'm just wondering if I bridge pin 6 and pin 7 together on that IC, whether that'll do it or whether it will completely kill it. I'm just tempted to bridge 6 and 7. Because I don't think phase matters, I think it's just purely driving, and if output 7, was it? Yeah, output 7 is completely dead, with no short, there's no apparent short on there, it might be safe to drive it. Although I didn't check for a short to DC supply, I only checked for a short to ground. I should check for that too, shouldn't I? What pin did I power supply for that then? VCC1, VCC2. Right, okay, so I'll check on pin 1 and 16 for a short. I'll do that. Hey, my stream just dropped right off and came back up again. That's weird. So I'll check pin 1, pin 16 for a short to that pin in case it's pulled high, not low. Just in case. No, nothing there. So that seems okay. It's not pulled to that state or that state. So it's not pulled low and it's not pulled high. But interestingly, oh, that's curious. I just found something else. Let me double check this. Pin 8. I'm getting basically a short between pin 8 and pin 1 or pin 16. Oh, sorry, pin 8. Yeah, 1 and 16, pin 8, 1 and 16. So pin 8 is minus 5 volt rail. 1 and 16 are the ground rail. So it's using negative supply, I should think about it too. Okay, and nice repair, thanks for hanging around. Catch you later. Okay. Why am I getting a short between here and here? Should I check this power supply locally to make sure I've got this minus 5 volt rail just here? What do you think? I think I should check that. Maybe that chip's not actually working. Maybe it's turned off and you've got leakage coming through. Let's measure across those pins, let's verify that. This way a little bit. You see that? Hopefully. Power on. Power this on. So between pin 8 and 1 and 16. So pin 8 is here. No, the power supply's there. Okay. So that's not it. It's interesting why I was getting a really low resistance there, but obviously it's fine because it's obviously working. So, not that. Okay, looks like the chips is dead then. That's the way it appears. Question is, can I find one of those? Right, I think what I should do is put this LO back together and reassemble this, put it back together, put the cover back on, basically start putting everything back together again, and then we look at this 10 MHz reference thing and find a way of injecting a new one. So yes, fun. So I-145 seems to feed a bias to the second differential negative input. They could shut down the signal on that path if wrong state. I-145. That one there. Because we get a signal here, right? Pin 10 has got a signal and pin 6 has got a signal. So they appear to be working, but 7 is not. So would that really shut that down on pin 7 if 10 and 6 are working? So that is a pull down resistor. Just adding some negative offset. Interestingly, on there. That's just pulling it down, yeah. Check voltages, yes, yes, check voltages, yes. Okay. I'm going to go back to what I said before. I'm going to put an external reference into it and see what happens. External reference. External reference. Let's just use my... Oh, is that going to be high enough level? It should be. Should be high enough level. Let's use this one. K frequency 10 megahertz. Modulation off. IF level 0 dBm, probably be enough. Maybe. Might not be actually. What's the most I can shove out of this thing? I don't think I can do 15. 11's the most I can do, so no. Maximum output. External reference. And I'll need to scope the output to see if it's come up. Let's change view so you can see what the hell I'm doing. Swing the camera back around to the scope. Right, so I'm injecting a 10 megahertz 10 dBm signal into the external reference. And we'll see if it changes anything. I doubt it, but you never know. No, it's still the same. And if I check pin 6, that's what we're getting on pin 6. That's not a very strong level though, it's only about 1 volt peak to peak. I'm not sure if that's right. Pin 10 was the input. So pin 10's 1 volt peak to peak input roughly as well. So it's like it's passing straight through. Is that right? Should it be amplified as well or not? Or is it just buffering? That's a bit curious too. But yeah, external input didn't help. So that ruled that out. Right then. IC4 needs replacing, I suspect. 1 volt's probably okay, you reckon? Okay. Yes, I'm thinking that 6 and 7 should be inverted versions of each other, so it does appear to be wrong, definitely. I'm just, you know, if something's running borderline, like the voltages are off or the signal level's too low, then maybe it's only just on the threshold of working kind of thing. That's what I was thinking, but I don't know, is 1 volt definitely alright? I mean, Helmut seems to think so, but I've got no idea. What was it saying here? Output voltage. Oh yeah, okay. One volt threshold. 0.9 to 1 volt threshold there. These are all negative voltages, aren't they? Which is so that's really what we want to look at is in here. not much for a window, is it? That's a pretty small window for the range. Am I missing something here? That's what it says, really. But yeah, 1 volt kind of stuff. Okay. So 1 volt's probably alright, but is it a bit too close to those thresholds? Don't know. I might need to take a more precise measurement of that because I'm very small windows very fast. Yeah, well, from what I saw on the scope, it's really close to these thresholds though. I mean, it's not really much in it. I might need to take some more precise measurements just to make sure it's actually meeting the requirements of the thresholds. It might be fine, but I'd like to see more of a throw than the minimums. Yeah, yeah. I understand that it's it's high speed, but so it's very sensitive. But what I'm thinking is the measurements I just took were around those levels, but are they enough to be triggering correctly on these levels? I mean, it's like a dirty square wave, wasn't it? But then I did have a ground probe hooked up. Let's hook up a ground probe, measure that again, and just take a more precise measurement and see what we actually get in here. I just want to be sure that it's definitely thresholds are okay. Okay, so pin 10. It's a bit messy. Anyway, 400 millivolts peak to peak. Oh, sorry, 400 millivolts OMS. 1 volt, 1.08 volts peak to peak. But as you can see, it's a little bit noisy. That's on pin 10. Pin 6 is at 1.3 volts peak to peak, 430 ohms, but again very noisy. And this is with my ground probe hooked up as well. That's 10 megahertz, obviously. And pin 7 is nothing at all. So 1.3 volts out, peak to peak, and 1.08 wasn't it in? Yeah, 1.08 in. So this is using AC coupling. Let's go DC coupling. Right, let's try and read this now. The minimum is 1.7 volts, or negative 1.7 volts, and the maximum is minus 580 millivolts, and that's the maximum. So it's going from 580 millivolts, sorry, negative, not 500 millivolts, to negative 1.68 volts. So that's fine, isn't it? That's well within those range. That's fine. That rules it out. At least I can be confident that's actually triggering correctly on the inputs. Just in case there's something wacky going on there, it's marginal. Helmet, okay, interesting. There's no load. The output load on that paired circuit, it's possible there's no load on the circuit connected. Current mode logic, not voltage mode. So if I stick my oscilloscope probe at 50 ohms, or my oscilloscope input at 50 ohms, that will load it down, and it might trigger something to happen, eh? Maybe we should try that just to be sure that's definitely not the case. Eh? We'll chuck 50 ohms on there and put some loading on the output and see if anything happens. 50 ohms times 1 probing. This is going to make this a bit big, so let's go down a bit. Okay, so we've got nothing there, basically. So, yeah. With this loading, it might be too much for it actually, because it's killing it. So, that's on pin 6. And this is on pin 7, still nothing, even with loading attached to it, so not that. So it looks like the chip is dead. Pretty sure that's what it is. I'm fairly confident that's what's wrong. Right, I need to find one. Right. OS. Let's try OS components first. It's free shipping, so I always try that first. Element 14 will do free shipping up above a certain order quantity, so MC10116 might be an equivalent as well, who knows. Is it 10H116? I wonder what difference is there. $7 each. What's the difference for the H, I wonder? Doesn't show it on here. No, this is suffixes, not middle fixes. Okay, let's try element 14. It might be the same equivalent part, but don't know. Buffer and line driver, it calls it. Yeah, right. Let's pull this up finally. Right. MC10116. No, element 14 don't have anything. So I'll put the same part number, that H in there. They've got those. $6 each. So what's the difference between the H and the other one? Let's look at the data sheet. It might be an insignificant difference. It's a functional pin attribution of the MC10116 with a propagation delay improvement. Okay, so it should be compatible then. Here you go, it's the MECL you talk about. Right. Okay, so this looks like it's likely to be the part I need to use. voltages look similar. Okay. So maybe this is what I should do, is get one of these. Or a few of them, like I tend to do. When I find a part I need to use, I tend to buy a bunch of them. So I can get 10 of them for $5.40, so that's $54 for 10, for 14. Or $7 for 2. Or $7 each for a pack of 2 from IRS, which is free shipping. Yeah, Element 14 is going to be cheaper. But then I'm going to charge shipping, so I don't know. I don't think I'll need 10 of them though. HE means high speed, okay. Yeah, so it looks like the parts will work. Futurelec have got them. I haven't purchased a Futurelec for years actually, you mention it. I have used them. Long time ago. Okay, hang on a second. It's bookmarked. Oh, it replaced it with a search instead. That's helpful. Come on. EPROMs, that's what I got from there. I got EPROMs from there. Okay. Futurelec. Sure, EPROMs from there. Anyway, something like that. Well, I did a search for EPROMs. There we go. Yeah. What series is it going to be under? Potentially this one, I suppose. I could just use the search function. Come on. Well, let's do search. I can't bother. Let's see, 10116. Triple line receiver, $2.20 each. That'd be Australian. I'm not sure what the postage cost would be. Yeah. I don't know what the postage cost would be. RS and I'll get free postage. This I won't get free postage. I think I've got a better data sheet than the other one. It's slightly better data sheet actually. Seriously? Can't download it, my ass. Let's just get this data sheet. Can't download, yeah. You can always download it, try hard enough. It's in it somewhere. Here we go. This data sheet. Here it is. It's just a matter of knowing where to look. Now I can download that data sheet and save a better one. Right. So Futurelec have got them. I'm inclined to just get the updated version. There shouldn't be any harm in using the newer one. and I can get it. I might, get 2 of them for $14 or something from RS and just have done with it. That way it's a relatively cheap repair, and I can have one as a spare for future. I don't want to invest too much money in it. I may or may not keep it. I may not. If it ends up being good, I might keep it. I don't know, but we'll see. It's quite compact for 20 gigahertz counter. Yeah, RS and Element 14 both have the H version, so I'm inclined just to get that one. So yeah, here it is here on the RS site, so they've got it. And they've got them in stock 8 working days, so you have to wait. In reality, it's like 8 working days before they ship it, so it's going to be 2 weeks till it arrives. Not too bad. What's Element 14 got for those? There's that one there. Come on, load. Slow internet. These are $6 each, so cheaper, $1 cheaper each one, if it ever loads. 4 to 5 days delivery. 16 in stock for that. So again, better, but postage cost will be involved. I don't really want to buy a whole bunch of them, since the first time I've come across a particular part being needed. It's not the sort of thing I see often. I think 5 in stock would be alright. 10's probably pushing it. $54 for parts. I think the cutoff was $70 for free postage. I think it was. I don't think I need anything else at the moment. That's the problem. Yeah, I have to figure something out. So I'm going to have to sort these out. I can't go any further until I get these chips. So that's a bit of a shame. But that's okay. I really should record some more video, because I've got into it a little bit and then stopped recording. Yeah. Right. Okay, so I think what I'll do is I'll leave it there. If I get the right windows. Where's my window gone? Got so many windows open now. Yeah, well, it means overseas stock of 8 days delivery. Yeah, so it's overseas, but it takes me a while. Yeah, pack of 2. Yeah, same thing. Coming 2 packs means you have to buy 2, so it'll give me 1 spare. Yeah, thing is, if I get 1 spare and it blows up again, I've only got 1 chance to get it right after that. I like to get a few. I like to have 4 or 5 spares. So, yeah. It's a challenge. Let's save that data sheet before I close it. Which one was that? Is that the SDH version? All right. Always save dollar sheets whenever I can. Anything I'm ever looking at, I save it. Right. I don't know. What else do I need? I've been stocking up with bits recently. I bought a whole bunch of tantalum capacitors, a whole bunch of those, about $200 worth of tantalum capacitors. As for the Datron project, the one 4700 calibrator, I know I'll need them. These common failures. What else do I need to buy? There's nothing else I know about right now that I need to buy. Because I did it the other day. I did an order a week ago of a bunch of stuff and I bumped it up then. Yeah. Could bodge the unused output of the driving section of U4 to the output. Close that off. Which unused section are you referring to? I would like to put it back together and just verify that that is what's wrong. I need more caps. Yeah, I've been stocking up on those, so I don't really need any more. Maybe we can have HP gear. Yeah, don't worry about helmet, it's fine. I'll just buy some brand new ones, it's alright. I'm not too worried about the money. I just don't want to waste a whole bunch of money on something I may never ever use again. But then that said, I do have a tendency of buying parts and keeping a stock of them. So if it's something I'm definitely keeping, right, a piece of test I'm definitely going to keep, like my Marconi 2955. I recently bought some parts for that because they're getting hard to find. And well, I'm going to keep this piece of gear. I'm not going to be getting rid of that anytime soon. So then I bought a bunch of them. Thinking, right, okay, I'm going to need a few. So I bought a few, even though they're expensive parts. Even though I may never need them. Pin 3 you're looking at. Okay. Oh yeah, okay. Could link pin 6 to pin 3 and see if it goes bang. Sounds like a plan. Also pin 7 to pin 3, not pin 6. Pin 7 to pin 3. Let's give it a go. Let's put it back together first. Let's reassemble it. I mean, nothing looks bad in there. I mean, the only thing I'd be worried about finding is a blown tantalum cap or something, you know. It looks fine. There's no sign of rework and that kind of stuff. It looks fine. So I'm quite comfortable seeing this back up again. Putting it back in. How well can you see what I'm doing? Not very well. There's a hole through there to that adjustment. So you have to take the cover off to do that adjustment. That's nice. Okay, that's that part. Try and balance everything in there carefully. Let's do the countersunk screws first, I think. Yeah, I'll do that with it. Don't want anything dropping off, that'd be a bit of a disaster. Come on. Yeah. Oh, at least we actually found something, so that's good. Took us a bloody long time to get there, and it should have taken us much less time than that. I was too busy looking at it with the architecture and trying to, I don't know, overcomplicate things, I suppose. Sometimes it is the simplest thing. If only someone suggested it. never mind. The screw hole there somewhere. There it is. Correct way around. That cable there. Let's hook these up before I drop that back in. It's a shame these aren't SMB connectors, that would have been so much easier. We've got SMB connectors. Now that's plug-on ones. Really easy to use, much preferred. Anyway. Can't do anything, I suppose. Nudge that one around a little bit. Yeah, seeing about the point where I said I was got to be careful about mixing the screws up. Yeah. I'm getting there. To figure out which of the other two screws it is. So we had a short one and some longer ones all the same. Right, one of them. That's the same, yeah, okay. This isn't really the right screwdriver for these screws, but it's working okay. Until then. The PZ screws, and that's a Phillips screwdriver. I should put this bottom guide back on again because I'm not going to be touching that. So the shorter screws will go in first. Hopefully these are actually the right places because somebody else may have had this thing apart before. Maybe the screws aren't even supposed to be here. Maybe they're from the other plate and someone's got them mixed up. Maybe, who knows. Maybe she'll be long screws in here. I've got no idea. Anyway, I was going to put it back as it was. It does seem a bit weird, you've got shorter screws. I'm suspicious that these two short screws are actually from the other plate, the other side, which hold that module in. And someone's just gone through and done exactly the same thing I did, pulled it all apart. Is that done? So we want to bridge across those two connectors and see if we get a working display. So I want to inject a signal in here. Do the same thing again, 1 gigahertz. No modulation, RF level 0 dBm, because that should definitely pick that up. Power on there. Power on here. Can you see it? Barely. So I'm going to use some tweezers to short between those two pins, because that could never go wrong, ever. 3 and 7. So pin 3 is here. Also got to be careful what I'm touching as well, because there's power supply stuff in this area too. So anyway, pin 3 is that one, and pin 7 is that one there. I can't see anything. Is it working? No, it is not working. So let's probe it with this. See if we're getting a signal coming through it or not. Yeah, clip this one somewhere. Huh. Guess what? I've now got an output. There's an output there now. Okay. And it's done on frequency. Oh, we're wasting our time with this. What's going on? Yeah. I probe it on the output to the connector. There we go. You have a signal. Bloody DC coupling. Yeah, 10 megahertz right there. So we have an output there now. What's going on? Did I somehow miraculously fix it by shorting across those pins? Is there something else happening which I don't understand? But there's still no signal on the counter though. So maybe I have to do those. I have to do those resets again. Maybe. So let's do. Was it 30? Oh God, how to do this again? 30. Shift store that, and 40 shift store that, and was it 70, wasn't it? Didn't do 70s, but I'll do it anyway. Yeah, that's fine. But yeah, nothing there. Still no signal, but we've got 10 megahertz there now. Oh, damn it. This one I thought we figured it out. Because I'll shove it on input B. Just verify that. There's the signal that comes up. So, oh, what's going on? We made no progress whatsoever today. That's brilliant. Oh man, unbelievable. Don't believe it. Yes, you're potentially correct. What I might do then, just to prove or disprove that theory, is unplug that coax again, power it up, recheck it. Hi Grums, how's it going? I see you here before. Well, unfortunately I don't have a connector to hook straight into the LO. I don't have the right kind of fittings. It's a connector type I don't have. So otherwise I've actually injected a signal into it. Would have one of the very first things I would have done. But unfortunately, I don't have a connector to suit that. So I need to actually find some. Got SMAs, got SMBs. I don't know what these are. Theory is maybe SMC. I'd have to look into it. So, right, I'm going to unplug that coax cable, disconnect that again, retest again. Actually, I'll power it back up, check it, see if it's still there, then disconnect the coax and recheck it. Okay, David, let's hang around. So I'll recheck it first in case its power cycle's killed it. No, still there. Okay, so power cycling seems safe. Let's disconnect the coax. If I can, because it's in the wrong place. It's a little bit awkward to get in there once it's installed. Okay, it's now disconnected. Let's flip it back over. I know you can't see what I'm doing, you have to take my word for it. Recheck. Yep, nothing there. Helmet called it. Oh, damn it. Oh, I guess I have to buy some nice chips then. Because they ain't there. Oh well. So what's the live stream like watching an empty chair? That's pretty good, isn't it? So 10 megahertz is there and getting into LO. So this is irritating. Six hours and got nowhere. Unbelievable. Damn. Okay. Was it 57, 58 was it, that page? So that reference was coming in down here somewhere, wasn't it? Where has it gone? Oh, we're looking at the wrong thing. I'm looking at the wrong thing. This one here, 59. So that is going into that synthesizer chip So back on the LO board. Yeah. Is it or isn't it right? Of course, now I put it back together and put it back in because I'm so confident it's fine. Right. So, yeah, we're back to this. So, reference comes in here, 10 megahertz. Will be coming in. We know it's there. I hope it's not this, whatever that is. So on this board, things I would be suspecting, just out of my gut feeling of things that can go wrong, right? Op amp is where I always start. I always look at op amps. Always. Now we are getting a output here, but it's not correct. So it could be the VCO is freewheeling and maxing out, or if it's not getting a proper feedback from the prescaler, this could be trying to control the voltage and maxing out one way or the other. Don't forget we got 386 megahertz, which is above where it should be, 30 megahertz above where it should be, and 265 megahertz, which is 30 megahertz below where it should be. Right? So those are the two frequencies we saw. So that makes you think that it's going to minimum range, maximum range, which is a typical symptom of a POL being unable to control a loop because it doesn't have feedback. So now we've determined the 10 megahertz coming in, so therefore that should be referencing correctly. My head is going into the POL section. Op amp will be passing through the voltage, so probably not that, although we've got this bypassing going through here as well, but that shouldn't matter because it's cap DC blocking on the cap. So it should be a voltage measurable here, which will be controllable, right? So that could be, is there any way of blocking that path? Not really. I don't want to backfeed into the op amp. One way to determine if it's working correctly or not is to remove the op amp, inject a voltage here, and that will then control the VCO manually. You should be able to manually control the frequency, right? So that's one way of determining whether the oscillator section, all that stuff, is working correctly. The other thing we can do is look at the frequency here after the prescaler versus the input to the prescaler. So the input and the output of the prescaler we could check to see if it's prescaling correctly, right? So IC4. We need to find out what that is. I could find out. Yes. We get frequencies coming out, right? So either the synthesizer, which is basically a POL, which has obviously got parallel programming, binary programming for the POL, so that's latching the in divider, divide by in counter. So we have that, we have a reference frequency, and this will be outputting a phase detector correction voltage, right? So if I look close, it should say PD. Yeah, PD, there we go. And it's also got lock detector. Ah, lock detector. LO lock, there we go. So that's something to look at. That's probably that display on the screen, is that 01. Locking thing going on there, which we're seeing. So when that's locked, that means the POL has a lock, which means the N divider, it makes sense versus the feedback frequency from the prescaler, and it's all under control. And we were seeing varying lock states with that POL, weren't we? That when we're looking at the LA lock, sometimes it's seeing 0, sometimes it's seeing 1. It's starting to make sense now. That starts making sense. Piecing things together. So POLs is something I'm familiar with. I'm used to POLs. I've done a lot of work with POLs. VCO circuitries, I'm comfortable with them. That I understand. That's fine. The context of how this works is a bit more interesting, but that's okay. So yes, this is basically, as said by Helmut, it's filtering as well, so it's buffering and filtering. So this has got a feedback circuitry in here, so it's already got a a phase detector filter network already here. That's what this section is. So it's got some built-in filtering with the IC. So it's doing some filtering, and then it's doing this as extra filtering as well, which is what this stuff is using, with a bit of feedback as well, negative feedback with filtering here. So zero ohm, what's that doing there? That's weird. Why would you have that? Test resistor across there. That doesn't make sense since it goes that way anyway. Weird. Maybe some circuitry thing there. So either the loop's not locking, it could be a bad op amp, which is this going from one end to the other, flipping over. So it's not actually controlling the loop. So I wouldn't rule that out completely, but it's less likely because it is an output, and it is a solid output, so it's definitely get a low state and a high state coming through. If there's nothing in the middle, that usually means that the POL isn't controlling the loop. So that's good. At least I understand this bit quite well. So in those kinds of situations, there's usually tantalum capacitors in the feedback loops and stuff like that to help provide precise smoothing and control. But there's no tantalum C, it's all ceramics. So not an issue there. So is it a feedback problem? Possibly. We've got some diodes here which are doing feedback. LO off, so that is turning it off. So that's disabling the prescaler, it would seem, in some way by shutting that off, and it's doing something here too. Not sure it's doing on pin 5, I have to find out what that device is. We have an oscillator running though, so that's no signal there. The oscillator is running. So there should be a signal input to the prescaler and an output of the prescaler. So I think that's probably the next thing I have to do is look at the prescaler, make sure the prescaling is working correctly, because if its divider ratios are wrong, or it's not putting anything out, then that will cause all kinds of problems. Failing that, we'll be looking at POL. So IC4 and IC2, we need to find out what they are. We're on page 260, right? Don't forget, 260. So, was that 213 around there, was it? I don't know, we'll find out. Keep IB, be past that one. Different prescaler, it's not the same one. IF, LO, here we go, so page 227, 260 and 227. IC4. Don't recognise either of those numbers. Let's look those up. So we've got SP8716 data sheet. So it's a input decoupling, really? That's weird. Okay, let's move this to a new window. So the SP8716, 8 or 9, 520 megahertz rated. So let's see if this matches up with what's in the diagram. And let's look at the other part too before I go away from this page. So it's NJ8821. Come on, PDF. Come on, slow the load. Yeah, that'll be great. Now I just need to get the actual file. Let's just grab the thing out of this web page. Give me a second. Don't like messing around inside web pages and there's viewers that I use. There we go. Where have we gone? I lost it now. I did have it. Gone. Where'd it go? Give me a second. Right. No, still not that one. Bloody hell, it's fighting with this one. Let's try a different website. I know it's not a great video for you guys, sorry, but I was trying to get this other data sheet out of here. How was it? It's a 821. Doesn't specifically list it. I hate that. Right. Let's try from this one. Give me a second. It's just taking a long time. That's not what I want to do. Oh god. This is being painful. Come on, where are you? Gotcha, I think. Yes. Right. pop this one out as well. So this is the obsolete POL. In theory. Which has built-in latches as well. That's interesting. So that's that part. Let's save that data sheet. It's NJ8821. Where's the other one go? I've lost it. Lost the window. There it is. It's funny, it's called Radio Mods Free. I own a website called Radio Mods. It's not this one. Anyway. Yeah. So we've got that pin out there. We want, was it? Oh God, for 260, wasn't it? Yeah. So you guys can see that text on here. So we've got pin 5 is going to that diode. That's input decoupling apparently. Pin 6 is input, that matches up. Pin 7 no connection, that matches up. Pin 8 VCC, yep. Pin 1 modulus control is marked as MC, which is a feedback from that device, which is interesting. That's more than I had noticed. I hadn't noticed that section actually. Pin 2 is output. Pin 3 is output. Pin 2 output VCC. Or is it output? Yes, it's output VCC here. For pin 2, which is interesting, and then 3 is output. So modulus control must mean the processor is controlling the divider ratio of the prescaler whilst it's active. That complicates things slightly. It's never easy, is it? Right, catch up with chat. No, they've got different connections, so. RF microwave, I don't know who they are. Not familiar with them. I'll make a note of that though. Array. I'll store that because it may be a case of trying to find one. So make a note. Okay, right. Where to from here? That's the question. I need to dig into this loop and find out what's going on. But as I've been live streaming for nearly 7 hours, it's probably time to stop. And it's just getting close to 30 degrees in here as well. Yeah, I think I'll take the LO module out. At least I can't just take it out and work on it next to the unit because the cables are so long, which is brilliant. That's really like the design. It's really nice. So you can do things like pull the thing apart, verify we do have the 10 megahertz at this point here in case there's a problem in this section. You never know. Maybe one of those diodes are shorted out and it's killing it. It's possible. But then I have to look at voltages through here, pre-scale the feedback. I have to look at this modulus control thing, see if there's some kind of way I can determine what's going on there. We know this bit's working because it's an output, so this bit must all be good up here. So I can at least rule that bit out, which narrows it down to this bit, which is good. Yeah, I mean, I could do that. I could solder on a coax, but I'd rather just get the right connectors at some point. I mean, if I don't have them now, I want to get them for future. That's what I've always done. If I've come across a connector I needed to have, then I'll buy some, and then I've got them for next time. It just means next time I don't have to mess around, you know. So, right. So there's not a lot to go wrong here, really. I mean, this should be fairly straightforward to troubleshoot, but I've had enough for today. You know, this will be another section, I think. So, I mean, this is all assuming that what I'm telling you to do is correct. Don't forget, this is believing I'm telling it to do 325 megahertz, and it's not doing it. And depending on what the input frequency is, this is changing. So, yeah, I think it should be doing what I'm telling it, about 325. I mean, I suppose I could probe these and see what's going on, make sure it was actually being told to change, but it wasn't changing, remember? So, yeah. But that would happen if you change to change and it doesn't change. That could be because the frequency it's seeing is wrong, or it thinks it's seeing is wrong, and so it may be out of range already. So therefore, it won't go any more out of range. So it's just flip-flopping between positive and negative extremities, depending on the triggering of the expectation from the feedback. Anyway, right, I'm going to cut this off. My throat is getting a bit sore from all talking. Doing the States. Okay. Well, I made note of that anyway, Ray, so thanks for that. If I do have trouble getting one, if I do need one, then at least I can have a look. When it comes to getting things like this going, it costs what it costs. You know, if it costs me $100 for the part with shipping, that's what it costs. You know, I don't like to chuck things away because of one part, which you could replace it at a small cost. You know. So, right, I'm going to cut this off. So it's too sore. So thanks everyone for tuning in. Give us a thumbs up as well. I always forget to say that until the very end. Always. So thumbs up if you like the video, even though it's long. We didn't really achieve anything. I think it's still interesting, poking around something. And I'll catch you next one. It won't be for a few weeks, I think. Actually, I'll tell you, hold on. When's the next weekend I've got off? My next weekend off is the 20th and 21st of March. So, another month away. That's my next day off. So, won't be until then. So, at least a month until the next live stream. So, I may have it fixed by then. We'll see. Right. I'll catch you later. Thanks for watching, and I'll see some other stuff. You see that 3D printer soon too. Right. Catch you later.